Before stars, planets, or even the light that illuminates our skies, there existed a concept so perplexing that it has haunted humanity for millennia: nothingness. What does it truly mean for something to emerge from nothing? Is it even possible to comprehend a state in which neither time nor space, as we understand them, had any meaning? These questions bring us to a place beyond the edges of scientific theory, into the speculative realms of philosophy and cosmology. Join us as we embark on a journey to explore the tantalizing enigma of what might have existed before time and space themselves, before the cataclysmic event we call the Big Bang. This period, a moment that precedes everything we know, is one that has baffled scientists, cosmologists, and philosophers alike. The mystery of this primordial moment gives rise to a variety of theories, each attempting to untangle the nature of existence before the universe as we know it came into being. Some of these theories look at what happened in the immediate aftermath of the Big Bang, while others attempt to unravel the possibilities of what could have occurred before the very fabric of reality was born. Among the most compelling of these ideas is the theory of cosmic inflation. This hypothesis suggests that in the first fractions of a second after the Big Bang, the universe expanded at a truly staggering rate, far faster than the speed of light. While cosmic inflation primarily addresses the rapid expansion that followed the Big Bang, it indirectly hints at the conditions that may have laid the groundwork for the universe's creation. By understanding how the universe grew from a tiny, hot, and dense state, scientists can trace the origins of space and time themselves. But cosmic inflation does not answer the question of what preceded the Big Bang. In the quest to understand this, we must turn to another perspective: the singularity. A singularity is an incomprehensible point in space where gravitational forces are so intense that matter is compressed to infinite density. If the universe began as a singularity, then all the laws of physics, our fundamental understanding of gravity, energy, and matter, break down completely. In this context, even the concept of before becomes elusive. In this pre-Big Bang scenario, time itself may not have existed, or at least not in any form that we could recognize. This challenges our very perception of reality, suggesting that the universe we experience could have emerged from a state where the traditional flow of time had no meaning. However, not all theories propose a singular starting point for the universe. Some cosmologists advocate for a cyclic model of the cosmos, where the universe goes through endless cycles of expansion and contraction. In this model, the cosmos begins from a hot, dense state, expands over time, and eventually collapses back in on itself, only to begin again in a new Big Bang. This theory suggests that our current universe is just one in a long series of cycles, each with its own unique variations, but all part of an eternal cosmic rhythm. In this view, the universe doesn't have a single point of origin. Instead, it is part of a timeless dance, constantly renewing itself in an endless loop. Another intriguing theory challenges the idea of a single universe entirely. The concept of the multiverse proposes that our universe is just one of potentially infinite others, each with its own set of physical laws, constants, and dimensions. In this scenario, the Big Bang could be seen not as the birth of all existence, but as a localized event, a bubble popping into existence in a much larger sea of universes. Each of these universes may operate under entirely different principles, creating a vast and varied landscape of realities. If true, the multiverse hypothesis radically alters our understanding of existence, suggesting that our universe may be just a small piece of a much grander cosmic mosaic. In addition to these grand theories, quantum mechanics introduces a layer of complexity to the understanding of the universe's inception. At the heart of quantum theory lies the concept of quantum fluctuations, tiny, random variations in energy that occur even in a perfect vacuum. These fluctuations, though minuscule, suggest that the fabric of reality is far more dynamic than previously thought. In the quantum realm, particles can appear and vanish seemingly without cause, driven by the inherent uncertainty of their behavior. This principle of uncertainty challenges our conventional notions of space and time, suggesting that the very nature of reality is much more fluid than we might have imagined. When applied to the origins of the universe, quantum mechanics offers a fascinating hypothesis. The Big Bang, according to quantum theory, may not have been a singular, smooth event. Instead, it could have emerged from a chaotic, bubbling quantum field where tiny fluctuations in energy gradually accumulated and gave rise to the universe as we know it. These fluctuations, though minute at first, could have been amplified over time, shaping the distribution of matter and energy that form the galaxies, stars, and cosmic structures we observe today. This notion of a quantum bubbling universe raises profound questions about the nature of creation itself. If the universe could emerge from a vacuum where energy seemingly arises from nothing, what does that say about the boundary between existence and non-existence? This understanding challenges the traditional view of nothing as an empty void, a simple absence of matter and energy. Instead, it proposes that nothingness is not a barren emptiness, but a rich, dynamic field teeming with potential. It is a place where quantum fluctuations can give rise to extraordinary phenomena, leading to the creation of entire universes. In this context, nothing becomes something profoundly active, full of possibility, and capable of generating the very essence of reality itself. In conclusion, the questions surrounding the origins of the universe remain as mysterious as ever. Whether it was the rapid expansion of the cosmos in the first moments following the Big Bang, the birth of the universe from a singularity, the endless cycles of a cosmic rhythm, or the spontaneous emergence of reality from quantum fluctuations, each theory offers a unique perspective on the enigma of existence. Together, they challenge our understanding of what it means to be, to exist, and to come into being. And in doing so, they invite us to reconsider our place in the vast, unknowable cosmos. Moreover, the consequences of quantum fluctuations reach far beyond the confines of our past, influencing our understanding of the universe's ultimate fate. These subtle energy shifts, as theorized by concepts like cosmic inflation, reveal that the universe is still being shaped by these fluctuations, even as it unfolds across time. The universe, as we observe it, may still be in the midst of its formation, continuously molded by the smallest quantum events, the interactions of which reverberate through vast stretches of space and time. This constant interplay between infinitesimal quantum movements and the grandest structures within the cosmos reveals a profound and interconnectedness, suggesting that everything in existence, from the minutiae of subatomic particles to the sweeping expanse of galaxies, is intrinsically linked in ways we can only begin to fathom. The idea of the multiverse further complicates and enriches this understanding. It proposes that our universe is merely one of many, potentially an infinite number, each existing within its own separate realm with distinct physical laws and conditions. This bold concept not only challenges our perception of what is possible, but also opens exciting avenues for exploration, particularly when it comes to the conditions that may have existed prior to the Big Bang. If multiple universes exist, it raises the tantalizing possibility that some of them may offer clues about the nature of reality before our universe was born. Imagine the wealth of knowledge that could be unlocked if we could peer into the origins of these other universes, examining the conditions and forces that shaped them in their infancy. One of the most captivating implications of the multiverse theory is its ability to support various models of cosmic origins. For instance, some propose that universes are born through collisions with other universes, an idea that suggests the birth of our universe was not a singular, isolated event. Instead, it could have emerged from cosmic interactions in a broader, more complex cosmic landscape. If this is the case, studying these interactions could provide valuable insights into the state of the universe before its inception. Researchers may uncover the parameters that governed the early universe and even discern the conditions that allowed for the creation of our reality. This approach would not only deepen our understanding of the origins of the universe, but also provide a broader context for how all universes might have come into being. The multiverse also offers a framework to consider how different sets of physical laws could have governed the early moments of each universe's formation. These laws might vary from one universe to another, and their differences would have shaped the specific characteristics of each universe, including its unique constants and forces. Such variations would inevitably influence the conditions leading up to their respective Big Bang events. If we can understand how these differing laws and constants operated in other universes, we might gain the insight necessary to understand our own universe's birth and, potentially, the nature of other Big Bangs that might have taken place across the multiverse. On a more speculative note, the conditions before the Big Bang itself might be intimately tied to quantum fluctuations, especially when considered within the framework of the multiverse. If our universe emerged from a quantum state, then studying these fluctuations across multiple universes could potentially reveal what preceded the familiar cosmic expansion. Rather than simply focusing on the events immediately following the Big Bang, this approach could provide a glimpse into the cosmic forces at play before the universe we know began its rapid expansion. As researchers continue to unravel the mysteries of the multiverse, we may come closer to understanding one of the most profound questions in cosmology: what existed before our universe came into being? Cyclical universe models add yet another layer to this enigma. These models propose that the universe undergoes an endless series of expansions and contractions, recycling itself across infinite time. According to this idea, after the universe reaches a maximum size, it begins to collapse under the influence of its own gravity. This collapse culminates in the Big Crunch, a catastrophic event that compresses all matter and energy back to an incredibly hot, dense state, reminiscent of the conditions that may have existed just before the Big Bang. In this cyclical framework, the universe is not a one-time event, but a continuous, eternal process of birth, death, and rebirth. One of the most prominent cyclical models is the oscillating universe theory, which suggests that the universe continuously cycles through phases of expansion, contraction, and rebirth. Each cycle begins with a Big Bang, giving birth to a new universe, shaped by the remnants of the previous cycle. This idea challenges the notion of a universe that exists only once, offering instead a vision of cosmic longevity, one where the universe evolves, transforms, and renews itself over endless time. In more advanced variations of this theory, such as those proposed by string theory, the universe could experience a cosmic bounce. In this model, instead of collapsing into a singularity, a point of infinite density, the universe's expansion slows down, halts, and then reverses, initiating a contraction that eventually leads to a bounce back into another expansion phase. This concept aligns with our current understanding of cosmic expansion, while also incorporating gravitational and quantum effects, offering an alternative to the conventional idea of a linear universe that began with a singular event and will end in a cold, lifeless fate. These cyclical models present a fascinating perspective on the universe, suggesting that it is not destined for a final, irreversible end, but instead could persist through an eternal cycle of destruction and renewal. The universe could be continually crafting new realities from the ashes of the old, ensuring its continuity across infinite eons. Cosmic inflation, a concept that seeks to explain the very early moments of our universe, offers another crucial piece of the puzzle. This theory describes an extraordinary period just after the Big Bang, during which the universe expanded at an astonishing rate, exponentially stretching in size in a fraction of a second. This rapid inflationary period helped smooth out any irregularities in the early universe, setting the stage for the cosmos as we recognize it today. The theory of cosmic inflation provides an elegant framework for understanding how the universe evolved from a hot, dense point to the vast, cooler expanse we observe today. However, the most intriguing question arises when we consider the universe before this expansion. Traditional models of the Big Bang suggest that time and space, as we understand them, originated from this singular event. But if the universe expanded from an even earlier quantum state, what might have existed before the Big Bang? Could there have been a time when space and time themselves had different properties, or perhaps did not exist in the form we know them? This question continues to fuel debates among cosmologists, pushing the boundaries of our understanding of the cosmos. As science pushes forward, the answers to these questions may forever alter our view of the universe's origins and its ultimate fate. However, cosmic inflation opens up a captivating realm of possibilities about the conditions and structures that might have existed long before the explosive birth of our universe. In fact, some groundbreaking theories suggest that our universe could have emerged from a preceding cosmic state, or even from fluctuations in a quantum vacuum, a field that persists even in the absence of matter. These theoretical landscapes are not bound by the idea that our universe is the first of its kind. Instead, they propose that our cosmos might be just one of many oscillating universes, or perhaps even a part of a vast multiverse, a collection of different regions where physical laws can vary from one to the next. Such ideas present a radical shift in how we understand time itself. Without a clear beginning, we are forced to confront the perplexing notion of what before be not truly means in this context. It challenges us to rethink existence on a much grander scale, provoking awe and wonder about what the universe might have been like before its current state. These questions, fundamental to our very understanding of reality, carry profound implications about the nature of existence itself. As researchers dig deeper into the mechanics of cosmic inflation, they are exploring not only the origins of the universe, but also the dynamic and ever-changing nature of the cosmos. This process is shaped by complex forces that may extend far beyond our present understanding of time, space, and physical laws. Cosmic inflation, along with theories surrounding the existence of realities prior to our universe, continues to inspire scientists and spark imaginations across the fields of cosmology and physics. One of the most intriguing aspects of these theories lies in their ability to challenge the idea of a static, unchanging universe. Rather, they present the universe as an ever-evolving, dynamic entity, formed through processes so intricate that they defy our current capacity to fully comprehend them. The interplay between inflationary theories and the possibility of an existence before our universe invites a cascade of questions, pushing the limits of human curiosity and scientific exploration. At the heart of these considerations lie singularities, mysterious points in the fabric of space and time where the laws of physics as we know them break down. Singularities are often associated with extremely dense objects such as black holes, but they are also linked to the very beginning of the universe itself. The most famous singularity, believed to have existed at the moment of the Big Bang, represents the point where all matter and energy were concentrated into an infinitely small volume. This concentration created conditions of incomprehensible temperature and density, sparking the birth of the universe as we understand it. In this singular state, the very fabric of time and space came into being, approximately 13.8 billion years ago, marking the inception of everything. However, singularities are not confined to the origins of the universe. They also appear in the centers of black holes, those enigmatic objects with gravitational forces so intense that nothing, not even light, can escape. When stars reach the end of their life cycles, they collapse under their own gravity, forming black holes that house these singularities. While singularities in black holes reveal much about the life cycle of the universe, they also raise profound questions about the ultimate fate of matter, energy, and even information itself. What happens to the information swallowed by a black hole? Can it ever be retrieved, or does it disappear entirely? These questions touch on some of the deepest mysteries in modern physics. Delving into the precursors to the universe, the concept of singularities leads us to consider theories like cosmic inflation. This idea posits that shortly after the Big Bang, the universe underwent an exponential expansion, vastly inflating in a fraction of a second. Some researchers suggest that the dynamic nature of singularities could hold the key to understanding what might have occurred before the Big Bang itself, or how the universe continues to evolve beyond the singularities at the heart of black holes. This line of thinking offers tantalizing glimpses into the origins of the cosmos, as well as the forces that could have shaped its future. In this context, singularities serve as not only a cornerstone for understanding the universe's origins, but also as a window into the complex processes that continue to shape its evolution. They push the boundaries of our knowledge, challenging us to rethink the very nature of existence and inviting us to explore the mysteries that lie beyond our current scientific grasp. Each new discovery brings us closer to uncovering the intricate, sometimes unfathomable forces at play in the cosmos, yet the deeper we look, the more questions arise. String theory offers a fascinating framework that seeks to unravel some of the most perplexing questions about the universe, particularly the enigma of what existed before the Big Bang, the moment that marks the birth of everything we know. At its core, string theory challenges the traditional view of matter, suggesting that the universe's fundamental building blocks are not point-like particles, but rather tiny, vibrating strings. These strings exist in multiple dimensions that go beyond the familiar 3 dimensions of space and 1 dimension of time. This radical concept introduces a new way of thinking about the cosmos and its origins, opening the door to the possibility that the universe may exist within a complex, multi-dimensional structure that extends far beyond human perception. String theory offers a potential explanation for the conditions that could have existed prior to the Big Bang, suggesting that these extra dimensions might represent various states of energy and existence. In such a scenario, the universe could have been in an extremely dense and chaotic state, and the strings themselves may have interacted in ways that we are still struggling to understand. These interactions, according to string theory, could have led to the explosive event that gave rise to our observable universe. In this light, string theory does not attempt to provide a definitive answer to the question of what came before the Big Bang. Instead, it offers a new framework for reconstructing the universe's earliest moments, a conceptual tool to help us understand the unfathomable conditions that may have existed in those primordial times. By proposing a universe that is multidimensional and deeply interconnected, string theory provides an intriguing avenue for exploring the boundaries of space, time, and existence itself. Thus, as we venture deeper into these cosmic mysteries, we find ourselves confronted not only with the vastness of the universe, but also with the profound and often elusive questions about its origins, its evolution, and the very nature of reality. In our quest to understand the fundamental forces that shape our universe, string theory stands as one of the most profound and ambitious frameworks. It does not merely offer theoretical insights, but invites us to reconsider the very fabric of reality itself. This theory, in its elegant simplicity, proposes that the basic building blocks of the universe are not particles, but tiny vibrating strings of energy. These strings, through their various vibrational patterns, give rise to everything in existence, from the smallest subatomic particles to the grandest cosmic structures. String theory, in its pursuit to unify all the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, offers a fascinating possibility. A single theory that could explain every force, every particle, and every interaction within the universe. It promises not only to tie together the mysteries of physics, but also to shed light on phenomena that have eluded scientists for centuries, such as black holes, the nature of space-time, and the origin of the universe itself. By embracing string theory, researchers are exploring profound questions about the very birth of the cosmos. For example, phenomena like black holes, once viewed as enigmatic objects with no possible explanation, may one day be understood in a new light through the principles of this theory. As we delve deeper into how gravity interacts with quantum mechanics, scientists are beginning to glimpse the conditions that could have existed before the Big Bang. These insights may help us bridge the gap between our understanding of what came before the universe we know, potentially allowing us to peer into a time before time itself. What was once thought of as an empty void is now imagined as a vibrant tapestry, rich with possibilities and governed by the dynamics of string theory. It invites us into a realm where the very concepts of time, space, and existence are not fixed, but fluid, malleable, and open to exploration. Despite the fact that string theory remains far from universally accepted, its implications are enough to inspire a rethinking of the most foundational ideas in physics. No longer is the nature of the universe seen as a static, predetermined structure. Instead, string theory opens the door to a universe in constant flux, governed by laws yet to be fully understood. What we once thought of as an empty void before the Big Bang, for instance, could now be a realm where untold possibilities exist, waiting to be discovered. Moreover, the exploration of dark matter and dark energy has become an integral part of the ongoing search to understand the origins and evolution of the universe. While invisible to the naked eye, these phenomena exert a profound influence on the cosmos, shaping its very structure and behavior. Dark matter, which accounts for roughly 27% of the universe, serves as a kind of unseen framework, ensuring the gravitational cohesion of galaxies, clusters of galaxies, and even larger cosmic structures. Its existence, inferred through the gravitational effects it has on visible matter, remains undetectable through conventional means. Without dark matter, galaxies would be unable to maintain the necessary gravitational pull to hold their stars and other components together. This would lead to an entirely different cosmic landscape, one far more disordered and chaotic. On the other hand, dark energy, which is believed to make up approximately 73% of the universe, remains one of the greatest mysteries in cosmology. Discovered in the late 20th century, when astronomers observed that distant supernovae were moving away from us at an accelerating rate, dark energy is believed to be responsible for the accelerated expansion of the universe. This strange force challenges our conventional understanding of gravity and space-time, pushing the very limits of our knowledge about how the universe operates on both large and small scales. The dynamic interplay between dark matter and dark energy has profoundly impacted the course of cosmic history. In the early moments after the Big Bang, dark matter played a pivotal role, clumping together to form the first stars and galaxies. As the universe continued to expand, dark energy emerged, overpowering the gravitational forces pulling matter together and driving galaxies further apart. This tug-of-war between invisible forces suggests a cosmos in constant motion, shaped not just by what we can see, but by vast, unseen forces that shape the very structure of reality itself. This raises fundamental questions about the nature of these invisible phenomena. What are dark matter and dark energy? Are they simply mathematical constructs necessary to explain certain observations, or do they represent something deeper, something yet to be discovered about the nature of the universe? As research continues, scientists hope to unravel the mysteries surrounding these enigmatic forces, bringing us closer to a deeper, more complete understanding of the cosmos. Among the most fascinating concepts emerging from cosmological research is the idea of the baby universe. This concept proposes that, just as our universe emerged from the Big Bang, smaller, self-contained universes could emerge from a parent universe. Each of these baby universes could follow its own set of physical laws, distinct from those governing our own universe. This idea aligns with certain interpretations of cosmic inflation, the theory that shortly after the Big Bang, space itself expanded at an extraordinary rate, potentially giving rise to pocket universes, small, isolated regions of space that could evolve into completely separate universes. Cosmological theories suggest that in the early moments after the Big Bang, fluctuations in energy could cause certain regions of space to inflate at vastly different rates. Some of these regions might continue to expand and eventually evolve into distinct universes, each disconnected from one another, yet all emerging from the same cosmic origin. This concept raises profound questions about the nature of reality. Is our universe the only one? Could there be countless others existing beyond the limits of our observable universe? The possibility of a multiverse, an infinite collection of universes, each with its own set of laws, opens up a new realm of possibilities, inviting us to reconsider the very limits of what we can comprehend. One of the most intriguing aspects of the baby universe theory is its connection to quantum mechanics, especially as explored by the late Stephen Hawking in his discussions about black holes. According to some theories, black holes might not only serve as traps for matter, but could act as gateways for new universes to emerge. At the heart of a black hole, the singularity, a point of infinite density, could provide the perfect conditions for the birth of a new universe, one that might have its own set of physical laws and constants. This idea challenges our understanding of both black holes and the nature of the cosmos itself. As research continues, scientists and philosophers alike grapple with the implications of these theories. How might these baby universes connect with the broader fabric of reality? Could they interact with our own universe, or are they isolated, separate realms? What are the fundamental laws that govern these universes, and how might they differ from those of our own? These questions continue to captivate the imagination, offering tantalizing glimpses into the boundless nature of creation. In the realm of philosophy, the concept of nothing presents one of the most profound and elusive mysteries of all. Nothingness, defined as the absence of anything that can be perceived, measured, or even imagined, stands in stark contrast to existence. While existence is marked by matter, energy, and phenomena, nothingness is defined by its complete lack of all these things. It raises questions that challenge the very foundation of our understanding of reality. What does it mean to exist? How do we even begin to conceive of nothingness? In quantum mechanics, there is a fascinating suggestion that even in what appears to be empty space, activity is taking place. What we perceive as nothingness is, in fact, a seething cauldron of potential. Particles arise and disappear spontaneously, a phenomenon known as quantum fluctuation. This suggests that even in the absence of visible matter and energy, the potential for creation exists, lurking just beneath the surface, waiting to manifest. This idea offers a glimpse into a universe far richer than we might ever have imagined, where the very concept of nothing is far from empty. Philosophically, the concept of nothing invites us to reflect on existence itself. What would life mean if there were no stars, no planets, no people? What is the value of existence when seen against the backdrop of nothingness? If we could fully comprehend the nature of nothing, perhaps we would better understand the miracle of everything that surrounds us. Every particle in our bodies, every blade of grass, every star in the sky becomes an extraordinary testament to existence, a remarkable phenomenon against a cosmic canvas of emptiness. As we continue to explore the mysteries of nothingness, we are drawn into a deeper appreciation for the existence that fills our universe and the infinite possibilities that might lie just beyond our grasp. The concept of nothingness, as both a philosophical and scientific puzzle, challenges the very core of human understanding. It pushes the boundaries of what we know and invites an endless exploration into the nature of reality itself. As we contemplate the existence of nothing, we are forced to confront fundamental questions about creation, the origins of the universe, and our place within it. If nothingness can exist and somehow transition into something, we are compelled to consider the very nature of being. What does it mean to exist? And how do we understand the relationship between what is and what could be? In grappling with these questions, we begin to realize that existence is not merely about being present, but also about appreciating the delicate balance between the known and the unknown, between being and non-being, between existence and potential. Throughout history, thinkers have engaged with the notion of nothingness, reflecting on its implications for existence, reality, and meaning. In ancient Greece, the philosopher Parmenides argued that nothingness could not truly exist. For him, to speak of nothingness was to speak of the absence of being, a contradiction in itself. Parmenides believed that existence in its most fundamental sense was the only certainty. Everything else was mere illusion. This idea laid the foundation for centuries of philosophical inquiry into existence versus non-existence. As philosophy evolved, other thinkers built on Parmenides' ideas and examined the tension between being and nothingness from various angles. One such philosopher was René Descartes, whose famous statement, cogito ergo sum, I think, therefore I am, brought a new perspective to the conversation. Descartes suggested that even in moments of doubt or uncertainty, the very act of thinking proves the existence of the self. He distinguished existence as something innate to the self, asserting that one must first acknowledge their own existence in order to even entertain the notion of non-existence. In this way, Descartes introduced a crucial idea. To confront nothingness, one must first affirm being. But this raises a question. How do we conceptualize existence when it is bound up with the potential for its opposite, nothingness? This tension between being and nothingness has remained a central theme in philosophical and scientific discourse. In the 20th century, the existentialist movement brought nothingness to the forefront of modern thought. Philosophers like Jean-Paul Sartre and Martin Heidegger explored the implications of nothingness in the context of human existence. Sartre, in particular, emphasized that nothingness is essential to human freedom and identity. He argued that the recognition of nothingness, the acknowledgement that life lacks inherent meaning, forces individuals to confront the responsibility of creating their own purpose. Sartre suggested that we are faced with the freedom to choose, but this freedom is both a gift and a burden. In a universe that offers no predetermined meaning, we must confront the emptiness that surrounds us and, through our choices, create our own significance. This existential view, which sees nothingness as both an absence and a catalyst for human freedom, continues to shape philosophical discussions today. As we engage with these ideas, we are reminded that nothingness is not simply an empty void. It is a space of potential, a fertile ground from which new ideas, realities, and possibilities can emerge. This recognition transforms nothingness from a passive absence into an active force that drives both human creativity and existential reflection. In the realm of cosmology, the concept of nothingness becomes even more perplexing. The universe, as we understand it, is not truly empty. Even in the seemingly empty vastness of space, quantum fluctuations constantly occur, suggesting that nothing is never truly devoid of activity. In physics, nothingness is a complex and dynamic concept filled with potential energy and fluctuating fields. This idea challenges our traditional notions of emptiness and raises profound questions about the origins of the universe. If the universe emerged from nothing, how did this transition occur? How can something as vast and complex as our universe arise from a state of nothing? Theories like quantum mechanics propose that particles can spontaneously emerge from a vacuum, suggesting that the act of creation might be a natural occurrence, one that occurs in a space we have yet to fully understand. Such theories blur the line between existence and non-existence, further complicating our understanding of the universe's beginnings. If nothingness is not truly empty, what does that say about the origins of everything? The interplay between science and philosophy becomes evident as both fields grapple with these questions, each offering its own insights and challenges. As scientists explore the mechanisms that govern the universe, philosophers provide the critical context for understanding the implications of those discoveries on our sense of existence and reality. The philosophical debates surrounding nothingness also raise questions about time, space, and causality. What happens to our understanding of these concepts when nothingness, in its true sense, is not empty? For instance, if nothing is a state without properties, does this mean time and space, as we understand them, lose their meaning in the absence of being? Can we even imagine a state of true non-being, or are we simply unable to conceptualize it because our minds are bound to the very frameworks of existence? As we delve deeper into these profound questions, we are invited to rethink our models of the universe's origins and to engage with the paradoxical role that nothingness plays in shaping both the cosmos and our understanding of it. The search for meaning, whether driven by existential reflection or scientific inquiry, continues to flourish in the face of this cosmic silence. In this way, nothingness, far from being an empty void, becomes a paradoxical catalyst for exploration, urging both scientists and philosophers to push the boundaries of what we know and to seek answers to questions that lie at the very heart of existence itself. Ultimately, the debate over nothingness complicates our understanding of the universe and our place within it. Whether in the context of philosophical inquiry or cosmological theory, nothingness challenges us to rethink everything we thought we knew about being and non-being. The tension between these opposing forces continues to fuel both existential reflection and scientific exploration, driving us to search for meaning in a universe that may in some ways be as empty as it is full of potential. In the vast, unfathomable expanse of the cosmos, where the stars burn with ancient light and galaxies swirl in an eternal dance, the existentialist perspective offers a unique vantage point, one that weaves together the threads of philosophical contemplation and scientific exploration. This perspective is not just an intellectual pursuit, but an invitation to question, to probe the very essence of our existence. It encourages us to confront the implications of nothingness in the universe, and in doing so, it transforms the void from a mere absence into an open frontier for discovery. Through this lens, we are invited to explore the mysteries that lie beyond our understanding of everything, leading us to delve into profound questions about the origins of existence itself. At the heart of this inquiry lies the enigmatic idea of creation from nothing, an idea that has sparked centuries of philosophical debate. If the universe, with its vast galaxies, stars, and intricate forms of life, emerged from a state of absolute nothingness, then we must ask, what does this imply about the very nature of creation? What does it mean for something to come into being if there was once nothing? This question reaches into the core of our understanding of causality, of time, and of the very beginning of the universe itself. The idea that something can emerge from nothing challenges our conventional understanding of cause and effect. It invites us to rethink the linearity of time and the fundamental principles that guide our perception of reality. How could the universe, with all its complexity, spring into existence without a cause, from a state that was devoid of both matter and energy? This notion compels us to ask, if nothingness once existed, does it still exist, or is it merely a temporary state, a brief pause in the unfolding narrative of the universe? This leads us to the nature of nothingness itself. Is it truly an absence, a void without substance, or does it possess properties of its own, waiting to be understood? The renowned philosopher Martin Heidegger explored this idea in his seminal work, Being and Nothingness, suggesting that the very concept of existence cannot be fully understood without confronting non-existence. For Heidegger, nothingness is not simply the negation of being, but a profound, active force in its own right. This challenge forces us to confront the limits of our own understanding, to grapple with a concept that seems both alien and intimately familiar. Can we truly describe absence using the language of presence, or are we limited by the very words and ideas we have to work with? At the same time, these questions have far-reaching implications for how we think about purpose and meaning in life. If the universe arose spontaneously, without a clear guiding force or predetermined plan, does this imply that the meaning of life is something we impose upon the world, rather than something inherent within it? Are we simply products of chance, or is there a deeper, hidden order guiding the unfolding of the cosmos? This tension between randomness and design, between chaos and order, is one of the most fundamental questions that humans have grappled with throughout history. These philosophical inquiries are not merely abstract. They resonate deeply with our own experiences, beliefs, and understandings of the world. They compel us to reflect on our place within this vast, intricate web of existence. As we contemplate the emergence of everything from nothing, we are invited to consider our own journey through life and the mysteries that lie beyond our grasp. This search for meaning is not just a matter of intellectual curiosity. It is a deeply personal quest that connects us to the cosmos itself. Eastern philosophies, particularly those rooted in traditions like Hinduism and Buddhism, offer their own rich interpretations of existence and pre-existence. In these traditions, the concept of a continuous cycle of birth, death, and rebirth provides an alternative to the linear understanding of existence that is more prevalent in Western thought. Hinduism, for example, teaches that the soul, Atman, is not a single, unique entity, but rather a part of a larger cosmic reality that exists in various forms across countless lifetimes. This cycle of reincarnation is governed by the principles of karma, the law of cause and effect, and dharma, the moral and ethical order of the universe, with each individual's actions shaping their future experiences. The ultimate goal in Hindu thought is liberation, or moksha, which represents freedom from the cycle of reincarnation and a return to oneness with the divine. This view of existence as a continuous, cyclical process stands in stark contrast to the Western linear perspective, which is often shaped by religious traditions like Christianity. In Christianity, for instance, the soul is believed to be created by God at the moment of conception, with each person's earthly life viewed as a test for their eternal destiny. In this framework, personal identity and purpose are deeply tied to the moral choices made within a single lifetime, and salvation is the ultimate goal, rather than liberation from an endless cycle of rebirth. Buddhism shares similarities with Hinduism, but places a stronger emphasis on the transcendence of suffering. The cycle of birth, death, and rebirth is seen as a source of suffering, and the goal is to break free from this cycle through enlightenment, reaching a state of deep wisdom and compassion that leads to liberation, or nirvana. This pursuit of liberation is not just an individual quest, but one that emphasizes the interconnectedness of all beings. encouraging individuals to cultivate mindfulness and compassion in their daily lives. These diverse philosophical traditions offer varying interpretations of pre-existence and the nature of reality, but they all seek to answer the same fundamental questions. What is the nature of existence? What is our place within the cosmos? And how can we find meaning and purpose in a universe that seems so vast and indifferent? As we explore these questions, we discover a rich tapestry of human thought that spans cultures and centuries, each tradition offering its own unique insights into the mysteries of life. The concept of creation from nothing also challenges long-held beliefs about causality and the nature of time. In our everyday experience, we tend to assume that every effect must have a cause, that events unfold in a linear, predictable sequence. Yet the idea of something emerging from nothing disrupts this neat framework, suggesting that the universe might not operate according to our intuitive understanding of cause and effect. In the realm of modern cosmology, some theories propose that the universe itself may have arisen from a quantum vacuum, a state of nothingness that is not truly empty, but filled with fluctuations of energy and particles that could spontaneously arise. This concept of spontaneous generation, though seemingly paradoxical, has profound implications for how we think about the origins of the universe. If existence can emerge from a quantum vacuum without a pre-existing cause, then the classical understanding of causality becomes much more complex and nuanced. Philosophers and scientists alike are grappling with this idea, as it challenges not only our understanding of the universe, but also the very frameworks we use to think about reality itself. The more we explore these phenomena, the more we realize that our conceptual frameworks are often inadequate to describe the true nature of the cosmos. In the end, the exploration of nothingness, creation, and existence invites us to rethink everything we thought we knew about the universe. It pushes us to confront the limits of our understanding, to question the very foundations of reality, and to open ourselves to new ways of thinking. The mysteries that arise from the idea of something from nothing are not just academic. They resonate deeply with our own experiences and our search for meaning. And as we continue to seek answers to these profound questions, we are reminded that the universe, in all its complexity, remains a vast and wondrous mystery, waiting to be explored. As we dive deeper into the mysteries of the cosmos, we are confronted with profound questions that stretch far beyond the bounds of conventional understanding. These questions, ranging from the smallest particles to the vastest galaxies, challenge not only our grasp of the universe, but also our comprehension of the fundamental laws of physics. At the heart of these inquiries lies an even more perplexing concept: the paradox of something emerging from nothing. This enigma doesn't merely question the nature of causation. It beckons us to rethink the very foundation of existence itself. It propels us into a rich and complex intersection of philosophy, physics, and metaphysics, leading us to explore the deepest layers of reality and our place within it. One of the most intriguing aspects of this cosmic journey is the philosophical notion of the void, which holds particular significance in our exploration of the universe's early days. In cosmology, the void is often understood as the absence of matter, a vast, empty space in which nothing seems to exist. This idea resonates with theories about the conditions of the universe at its inception. Before the emergence of matter and cosmic structures, the early universe was a nearly homogeneous expanse of energy and radiation, devoid of the matter we recognize today. It is a state that defies imagination, a kind of nothingness that holds immense potential. In the moments following the Big Bang, the universe was an incredibly dense and hot place, where fundamental particles were barely able to form. As it began to expand, the void became more pronounced, growing alongside the universe itself. This vast, seemingly empty space was crucial not just for the universe's expansion, but also for the emergence of galaxies, stars, and other cosmic structures. The void wasn't simply a passive emptiness. It played an active role in the gravitational clumping of matter, creating the dense regions where galaxies would eventually form. In this way, the void is not merely the absence of matter, but rather a fundamental component of cosmic evolution. Understanding the void's role leads to even more profound questions about the nature of reality. It prompts us to reflect on the transition from nothingness to something, an existential shift that marks the history of our universe. This shift, from a state of absolute emptiness to a rich tapestry of cosmic structures, invites contemplation about the fundamental nature of creation. What drives the universe to shift from a void to an expansive, complex system? What laws govern these transitions? These inquiries delve into the very boundaries of our scientific knowledge, blending empirical investigation with abstract philosophical reflection. In exploring the void and its implications, we are reminded that the universe is not just shaped by what exists, but by what does not. The interplay between presence and absence forms a critical aspect of our understanding of the early universe. By merging scientific inquiry with philosophical reflection, we deepen our comprehension of cosmic origins, further enriching our quest to understand the forces that shape not just the cosmos, but our place within it. Humanity's view of creation and destruction has also long influenced how we interpret the cosmos. Throughout history, cultures have woven intricate narratives about the origins of the universe, often reflecting their own experiences with birth, death, and the cyclical nature of life. These myths and stories are not merely fanciful tales. They embody the deep human desire to understand the mysteries of existence. In many traditions, creation is closely linked with spirituality, marking the beginning of the cosmos as an act of divine will or cosmic necessity. These stories reflect the hope for renewal, often symbolized by the birth of stars or the emergence of galaxies from primordial dust. On the flip side, the concept of destruction is equally significant. Destruction is not seen as an end, but as a precursor to new beginnings. For instance, the death of a massive star, which ends in a cataclysmic explosion known as a supernova, doesn't mark the termination of the cosmic cycle. Instead, it disperses vital elements into space, which will eventually coalesce to form new stars, planets, and even life. In this way, destruction and creation are inseparable, forming a cyclical process that drives the ongoing evolution of the universe. When viewed through the lens of modern scientific theory, such as the Big Bang Theory, these concepts take on new layers of meaning. The Big Bang, often regarded as the birth of the universe, resonates with human notions of creation and birth. Likewise, the universe's eventual fate, whether it will collapse back in on itself or continue expanding indefinitely, sparks reflections on the nature of destruction, renewal, and cosmic cycles. As we examine these themes, we begin to see how human concepts of creation and destruction offer rich insights into the universe's ongoing evolution, helping us relate our own experiences to the vast, mysterious processes unfolding on a cosmic scale. The early universe itself was a place of extreme conditions, vastly different from anything we experience today. During the Planck era, which spanned from 0 to approximately 10 to the power of negative 43 seconds after the Big Bang, the universe existed in a state of extraordinary density and temperature. At this time, all four fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were unified into a single, all-encompassing force. This means that the laws of physics, as we know them today, were not yet distinguishable, and the very fabric of space and time behaved in ways that are almost impossible to comprehend. Temperatures during this era were estimated to be around 10 to the power of 27 degrees Celsius, so hot that the very existence of matter as we know it was impossible. The universe was a boiling soup of energy and radiation, where particles were continually being created and destroyed in a never-ending cycle. At such extreme conditions, even the fundamental building blocks of matter, quarks, electrons, and other elementary particles, were in a constant state of flux. Matter, as we understand it today, had not yet formed, and the universe was not yet a place where the laws of physics could operate as they do now. However, this chaotic and seemingly formless environment set the stage for what would come next. As the universe expanded and cooled, the forces that had been unified began to separate, and particles began to take on distinct identities. This phase, known as the Grand Unification Era, marked the beginning of the universe's transition from pure energy to the formation of the first building blocks of matter. The characteristics of the Planck era, this tumultuous and extraordinary time, continue to captivate scientists today as they strive to unravel the mysteries of the universe's earliest moments. In reflecting on these cosmic origins, we gain a deeper understanding of the fundamental processes that shaped our universe, not just in terms of matter and energy, but in terms of the very structure of existence itself. As we continue to probe the early universe, we are reminded that the most profound mysteries often lie at the intersection of science, philosophy, and the very nature of reality. And in this pursuit, we are not merely studying the past, we are contemplating the very essence of existence, what it means to be, to become, and to understand the cosmos in all its complexity. The laws governing the early moments of the universe, particularly during the Planck epoch, are believed to hold profound implications for our overall understanding of the cosmos. They offer potential insights into the origins of space and time, and they could provide a window into the fundamental nature of reality itself. One of the most pressing questions that emerges from this era is whether a theory of quantum gravity can successfully describe this crucial moment in the universe's history. If such a theory can be developed, it could unlock the secrets of the universe's birth, and in doing so, offer a more comprehensive understanding of its subsequent evolution. The conditions that prevailed during the Planck era were not only foundational, but they also paved the way for everything that followed. The mysteries wrapped up in this brief, seemingly infinitesimal period serve as a reminder of just how much there is still to discover about the universe's earliest moments. These enigma-laden moments challenge the boundaries of modern physics and our comprehension of reality itself. The Planck epoch, which occurred within the first 10 to the power of negative 43 seconds following the Big Bang, represents a time when the very fabric of space and time operated under rules that defy the basic principles of our everyday experience. At this infinitesimally brief moment in time, all four fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were unified. The energies involved were so extraordinarily high that quantum effects ruled the day. Space-time itself was likely chaotic and turbulent, a far cry from the smooth, predictable framework we observe today in our current understanding of the universe. In our everyday experience, time flows steadily, and space is described in familiar dimensions. However, at the Planck scale, the fabric of space-time behaved in a way that our conventional laws of physics simply cannot fully capture. Imagine time not as a continuous, flowing river, but instead as a collection of discrete moments, each separated by quantum fluctuations. In this context, the conventional notions of beginnings and ends lose their clarity, challenging our understanding of causality and the flow of events. Additionally, the very dimensions of space-time that we take for granted seem foreign, as distances and spatial separations were on a scale so minute that they defy the comprehension of our senses and current physics. The dimensions that define our world either did not exist or were drastically different from those we know today. In this realm, space-time itself may have been so compact that it was difficult, if not impossible, to distinguish between what we now define as space and what we perceive as time. Theoretical physicists have suggested that what we think of as the fabric of the universe during this period was fluid and pliable, continuously shaped by quantum uncertainties. To truly grasp the nature of the universe during the Planck epoch requires us to abandon conventional notions of space and time and embrace a reality where physics diverge sharply from the rules governing our macroscopic world. As the universe expanded and cooled, these unified forces began to separate, and space-time settled into the structured framework we are familiar with today. This transition set the stage for the rich, complex cosmic events that followed, eventually giving rise to the universe as we know it. High-energy physics plays a pivotal role in shedding light on the mysteries of the universe, particularly in understanding the moments leading up to the Big Bang. This branch of physics focuses on probing the fundamental particles and forces that govern their interactions, especially under extreme energy conditions far beyond what we encounter in our daily lives. By studying high-energy scenarios, scientists are able to recreate conditions akin to those thought to have existed in the universe's infancy. These efforts provide invaluable insights into the origins of the cosmos. When we venture into the moments just before the Big Bang, we enter a domain where current physical theories are especially critical. Models like quantum field theory allow physicists to explore the behaviors of fundamental particles in environments where energy densities were extraordinarily high. This research offers clues about how the fundamental forces, such as gravity and electromagnetism, may have functioned together during that chaotic period. Notably, high-energy collisions in particle accelerators, like the Large Hadron Collider, simulate the extreme conditions of the early universe, offering opportunities to observe the interactions of particles that might have occurred during that time. Moreover, high-energy physics delves into phenomena like the inflationary model, which posits that the universe underwent an incredibly rapid expansion just moments after the Big Bang. This theory suggests that quantum fluctuations in the energy field may have seeded the large-scale structures we observe in the cosmos today. By studying these fluctuations and the properties of particles under extreme conditions, researchers aim to piece together a clearer picture of how the universe evolved from its initial singularity. As scientists continue to push the boundaries of high-energy physics, each new discovery adds a layer of understanding to the complex narrative of cosmic history. While many questions about the events leading up to the Big Bang remain unanswered, the insights garnered from high-energy physics continue to bring us closer to unraveling the intricate tapestry of the universe's beginnings. In addition to high-energy physics, scientists have developed several innovative methods to study the conditions of the early universe, despite the challenges posed by limited observational evidence. One of the primary tools in this investigation is the field of cosmology. Cosmology combines theoretical models with available observational data to reconstruct the infancy of the universe. By analyzing the cosmic microwave background radiation, the afterglow of the Big Bang, researchers can glean vital clues about the universe's state just a few 100,000 years after its birth. This faint radiation is remarkably uniform, yet it contains subtle fluctuations that reflect variations in density, offering critical insights into how matter was distributed across the developing cosmos. Beyond analyzing the cosmic microwave background, cosmologists also employ simulations and models based on the laws of physics to study the early universe. These simulations rely on the principles of general relativity and particle physics to replicate conditions just moments after the Big Bang. By adjusting various parameters within their models, researchers can explore how different initial conditions could have led to the formation of elementary particles, atoms, and eventually stars and galaxies. This type of modeling is essential for pushing the boundaries of knowledge because it allows scientists to explore scenarios that lie beyond the realm of direct observation, helping to construct a coherent narrative of cosmic evolution. Through these combined efforts, high-energy physics, cosmological studies, and simulations, scientists are slowly piecing together the story of the universe's earliest moments. Every discovery, no matter how small, adds to our understanding of the profound forces that shaped the cosmos. While much remains unknown, each breakthrough takes us one step closer to unraveling the mysteries of the universe's origins. Scientists are deeply engaged in exploring the distribution of large-scale structures, such as galaxies and galaxy clusters, across the present-day universe. The way these structures are arranged today offers crucial insights into how they formed and evolved over time, which in turn helps researchers uncover the initial conditions that governed their development. One key factor that shapes these cosmic structures is dark matter, a mysterious substance that does not emit or interact with electromagnetic radiation in the same way as ordinary matter. Dark matter plays a vital role in how galaxies cluster together, and by studying its effects on these arrangements, scientists can infer important characteristics of the early universe. Moreover, researchers are now turning their attention to gravitational waves, ripples in the fabric of space-time caused by massive events such as the merging of black holes. The detection of these waves has opened up an entirely new avenue for studying the cosmos. They allow us to observe high-energy phenomena that occurred during the universe's formative moments, potentially shedding light on the conditions that existed in the very earliest stages of cosmic history. By combining direct observational data, theoretical models, and emerging technologies, scientists are piecing together the story of the universe's beginnings, revealing the complex and awe-inspiring history that shaped everything we see today, from the smallest particles to the largest cosmic structures. At the core of this narrative is the universe's early state, characterized by extreme conditions of density and temperature. Just moments after the Big Bang, the universe existed as an unimaginably hot and dense environment. Temperatures soared to trillions of degrees, causing matter and energy to exist in a unique state known as quark-gluon plasma. In this phase, the fundamental particles, quarks and gluons, were not confined within protons and neutrons, but moved freely, creating an environment where the very fabric of the universe was still being formed. As the universe began to expand, it cooled dramatically, allowing quarks to combine and form protons and neutrons. Approximately 3 minutes after the Big Bang, the universe had cooled sufficiently for these particles to undergo processes that led to the creation of light elements like hydrogen and helium. This era, known as Big Bang nucleosynthesis, marked the beginning of the elements that would play a pivotal role in the future formation of stars and galaxies. The proportions of hydrogen and helium produced during this period set the stage for the evolution of the universe's larger-scale structures. Gravity, acting upon the varying densities in different regions of space, began pulling matter together. Some regions became dense enough to collapse into celestial bodies like stars and galaxies, while others, with lower density, expanded and cooled, creating vast voids between the clusters of galaxies. Understanding the early universe's density and temperature is crucial in deciphering the cosmic microwave background radiation, the faint afterglow of the Big Bang. This radiation, still detectable today, holds an imprint of the universe's state at the moment it transitioned from a hot, dense environment to the cooler, more expansive cosmos we see now. By studying this radiation, scientists can unlock secrets about the conditions that shaped the early universe and gain deeper insight into cosmic history. The mysteries of the early universe also invite exploration through the lens of quantum mechanics, which challenges our conventional understanding of reality. At the quantum level, particles behave in ways that defy our everyday experiences. Instead of existing in fixed states, quantum particles exist as probabilities capable of being in multiple states at once until measured. This idea opens fascinating possibilities for how we might think about the universe before it came into being. If particles can fluctuate and exist in a range of potential forms, could the fabric of reality itself have been a vast sea of probabilities, rather than a concrete and tangible state? Quantum fluctuations provide a possible answer. These fluctuations suggest that even in the emptiest voids of space, energy can spontaneously appear and disappear, causing variations in energy levels. It is theorized that such fluctuations may have contributed to the birth of the universe itself. Before the Big Bang, the universe might not have existed in the traditional sense, but rather as an unmanifested potential, a collection of quantum states waiting to emerge. This raises profound questions about the nature of reality itself, challenging the boundaries of space and time and opening up new ways of thinking about existence. Moreover, some theories, such as the multiverse hypothesis, suggest that our universe might be just one of countless others, each existing simultaneously. In such a scenario, a quantum realm could have existed before the birth of our universe, where different physical laws and constants could give rise to an infinite variety of realities. If our universe emerged from such a pre-existing quantum landscape, the implications for our understanding of time, space, and existence are profound. The idea that different universes could coexist, each with its own set of rules, pushes the boundaries of what we understand about the cosmos and raises new possibilities about the nature of reality itself. These speculative ideas, rooted in quantum mechanics, not only broaden our understanding of the universe, but also suggest that the origins of everything we know could lie within a realm of infinite possibilities. As we delve deeper into the mysteries of quantum theory, we may eventually gain the tools needed to navigate the terrain of what existed before creation itself. These concepts invite us to ask fundamental questions about existence. What does it mean to truly exist? And how do the probabilities that govern quantum systems shape our experiences? Gravitational waves, often described as ripples in the very fabric of space-time, provide another crucial piece in the puzzle of understanding the universe's early stages. These waves carry information about some of the most violent and energetic events in the cosmos. Their significance, particularly when it comes to the early development of the universe, cannot be overstated. Predicted by Albert Einstein in his theory of general relativity more than a century ago, gravitational waves were directly detected for the first time only recently, marking a groundbreaking achievement in cosmology. In the moments immediately following the Big Bang, the universe underwent a period of rapid expansion known as cosmic inflation. This process likely generated a multitude of gravitational waves, and by studying these cosmic ripples, researchers can gather invaluable information about the universe when it was only a fraction of a second old. The frequency and amplitude of these waves may offer crucial clues about the mechanisms that drove inflation, including the physics that governed the early universe's rapid expansion. By tapping into this new realm of gravitational wave astronomy, scientists have the potential to unlock even more secrets about the universe's birth and the forces that shaped its evolution. Gravitational waves serve as an extraordinary tool for scientists, offering an unparalleled opportunity to probe the most extreme and violent events in the cosmos. These waves, ripples in the fabric of spacetime, allow researchers to observe the aftermath of cataclysmic events such as the collision of black holes and neutron stars. These types of events, which happen billions of light years away and often long after the universe's formation, are pivotal in expanding our understanding of gravity, matter, and the very laws that govern our universe. Not only do these cosmic events contribute to our understanding of fundamental forces, but they also provide essential insights into the universe's evolution and the complex process through which structures like galaxies and clusters of galaxies formed. Each new detection of gravitational waves is akin to finding another piece of a vast, intricate puzzle, revealing the connections between the most energetic occurrences in the universe and the very fabric of space itself. The ongoing study of these waves offers a unique window into the deepest mechanics of astrophysical processes. As detection methods and theoretical models continue to advance, it is expected that gravitational waves will provide even more profound insights into the universe's mysteries. These ripples in spacetime promise to shine a light on the earliest moments of the universe, shedding new understanding on the forces that shaped everything around us. This emerging field represents the intersection of cosmology, astrophysics, and the most fundamental laws of nature, marking a thrilling chapter in humanity's ongoing quest to understand the origins of the universe. Another crucial piece of this cosmic puzzle is the study of cosmic background radiation. This faint, pervasive glow that fills the universe is a relic of the early cosmos, offering an invaluable glimpse into the universe's infancy. This radiation, originating from about 387,000 years after the Big Bang, marks the moment when atoms first formed and light could travel freely across the newly born universe. The cosmic microwave background, CMB radiation, provides a snapshot of the universe in its early stages, allowing researchers to explore the conditions that existed shortly after the Big Bang. Remarkably, this radiation is not perfectly uniform. Tiny fluctuations or variations in temperature exist, which point to areas of differing density. These fluctuations offer critical clues about how matter and energy were distributed throughout the young universe, unveiling the underlying dynamics of cosmic inflation, a period of rapid expansion that occurred in the first moments after the Big Bang. This process, which expanded the universe by a vast factor in an incredibly short period, set the stage for the structure we see today: galaxies, stars, and clusters of galaxies. While cosmic background radiation gives us a snapshot of the universe after its birth, it also raises some profound questions about the very nature of existence. The standard cosmological model describes the universe's origins, but does not directly explain what happened before the Big Bang. Theoretical frameworks like string theory or multiverse hypotheses suggest that our universe could be just one among many, offering a tantalizing vision of an expansive reality where the notion of before the Big Bang might not even make sense in a conventional way. As researchers continue to study the cosmic microwave background radiation, they are slowly piecing together the mystery of the universe's earliest moments. Every new discovery in this field moves us one step closer to answering fundamental questions that have puzzled humanity for centuries. And as technology advances, the hope is to gather even more detailed data, potentially unveiling secrets about the universe's infancy and offering insights into what might have existed before it took its first breath of light. The pursuit of understanding the universe's initial conditions remains one of the most exciting frontiers in cosmology. To unlock the true nature of the universe's origins, scientists are embarking on groundbreaking experiments and observations that could revolutionize our theories. One promising approach is the detailed study of the cosmic microwave background radiation, particularly the tiny temperature fluctuations within it. By refining these measurements, researchers aim to gain a better understanding of the density and distribution of matter in the early universe. This could provide crucial tests for inflationary theory, which posits that the universe underwent an extremely rapid expansion in its earliest moments. Another promising area of research is high-energy particle physics. The Large Hadron Collider, LHC, the most powerful particle accelerator on Earth, recreates conditions similar to those just moments after the Big Bang, allowing physicists to probe the behavior of fundamental particles and the forces that act upon them. By studying these high-energy collisions, researchers hope to uncover new particles or phenomena that could provide deeper insights into the dynamics of the early universe, potentially leading to revisions in current models. Gravitational wave astronomy is also poised to make significant contributions to our understanding of the universe's origins. Since the first detection of gravitational waves in 2015, this innovative technology has opened up an entirely new observational window, one that allows scientists to study the ripples in space-time generated by massive cosmic events like black hole mergers or neutron star collisions. These events, which occur in the farthest reaches of the universe, provide a unique perspective on the behavior of matter and energy in the earliest moments of the universe's evolution. The ability to study these phenomena directly could fundamentally reshape our understanding of how the universe evolved and provide new insights into the fundamental laws of physics. Together, these diverse fields of research, gravitational wave astronomy, cosmic background radiation, and high-energy particle physics, are converging to form a more complete picture of the universe's birth. As technology improves and new discoveries are made, scientists are getting closer to answering some of the most profound questions about the cosmos, including what happened in the moments before the Big Bang and how the universe evolved from a hot, dense state into the vast, structured cosmos we observe today. Dark energy research could reveal transformative insights that not only challenge, but also potentially redefine our understanding of the universe itself. Dark energy, a mysterious force that makes up roughly 70% of the cosmos, remains one of the most profound and enigmatic aspects of modern physics. Its elusive nature may provide vital clues about the infancy of the universe and the mechanisms that have shaped cosmic evolution over billions of years. By studying how dark energy influences the expansion of the universe, scientists aim to illuminate its role in the unfolding of cosmic history, offering a deeper understanding of the forces that shaped everything from galaxies to star systems. As we explore the broader implications of this research, it is becoming increasingly clear that dark energy may not only reshape our perceptions of the universe's origins, but could also revolutionize our understanding of the fundamental laws that govern celestial phenomena. This pursuit may bring clarity to the initial conditions of the universe, offering answers to questions that have puzzled scientists for centuries. The effort to understand dark energy is, in many ways, an effort to uncover the underlying structure of reality itself. In the early stages of scientific exploration, classical physics, epitomized by the work of figures like Isaac Newton, presented a vision of the universe that was both orderly and predictable. Under this framework, time and space were seen as immutable and absolute entities. Time was a universal, unchanging force, flowing in a single direction for all observers, no matter their relative motion. Space, on the other hand, was a static backdrop, unchanged by the events unfolding within it. This understanding of the cosmos worked perfectly well for most everyday experiences, but as the 20th century dawned, it became increasingly clear that these ideas were inadequate when faced with extreme conditions, such as those near the speed of light. The turning point came with Albert Einstein's theory of relativity, which fundamentally transformed our understanding of the universe. In 1905, Einstein introduced his special theory of relativity, challenging the Newtonian view by proposing that time and space are not separate, absolute entities. Instead, they are woven together into a single continuum known as space-time. This revolutionary concept meant that the flow of time could vary depending on the relative motion of observers. For example, a person moving at near light speed would experience time passing more slowly compared to someone at rest. This idea is famously illustrated by the thought experiment of the twin paradox, in which one twin journeys into space at near light speeds and returns younger than the twin who stayed on Earth. But the impact of Einstein's theories did not stop there. In 1915, he expanded his ideas to include gravity in the form of his general theory of relativity. He proposed that massive objects, such as planets and stars, warp the very fabric of space-time around them. This warping or curvature affects not just the paths that objects take through space, but also the passage of time. In stronger gravitational fields, such as near a black hole or even on the surface of Earth, time passes more slowly than it does in areas with weaker gravity. This effect, confirmed by experiments using atomic clocks, is one of the key predictions of general relativity and has far-reaching implications for our understanding of the cosmos. The transition from classical to modern physics represents a profound shift in how we view the universe. Space is no longer a passive void in which objects float, but rather an active participant in the cosmos, its structure shaped by the mass and energy it contains. Time, too, has become a malleable and relative experience, intricately tied to the movement of objects through space-time. These insights have altered everything from our understanding of the cosmos to practical applications like satellite navigation and global positioning systems, which rely on the very principles of relativity to function accurately. As we continue to delve deeper into the universe's most complex mysteries, the implications of relativity stretch far beyond mere theoretical physics. The concept of nonlinear time, for instance, introduces a compelling framework that could fundamentally change our understanding of the universe. Traditional models of time often assume a linear progression. Events unfold in a neat, sequential order with the definitive beginning, middle, and end. However, nonlinear time presents the possibility that events could be interconnected in far more intricate and unpredictable ways. Rather than following a single, unalterable timeline, the universe might be composed of cyclical loops, where the past, present, and future influence each other in ways that defy our everyday understanding of cause and effect. Nonlinear time also opens up new possibilities for understanding what happened before the Big Bang. If time itself is not a linear progression, but instead exists in a more complex, interconnected framework, then the traditional notion of a singular origin point for the universe may need to be reconsidered. Instead of a clear-cut beginning, the universe could have existed in a state of constant flux, with various timelines or parallel realities interwoven in ways that are beyond our current comprehension. Such ideas force us to reconsider not just the origins of the universe, but also the very nature of existence itself. Moreover, the inclusion of nonlinear time in our models of the universe could help us address some of the deepest mysteries of modern physics, especially in areas where classical concepts of time break down. In the extreme environments of black holes, for example, our usual understanding of time ceases to hold. At the singularity at the center of a black hole, where gravitational forces are infinitely strong, time and space as we know them may no longer function in predictable ways. A nonlinear framework might offer a richer, more flexible understanding of these phenomena, explaining the complex relationships between different cosmic events and how they unfold across time. This shift toward a nonlinear understanding of time also brings with it profound philosophical implications. If the past, present, and future are not distinct and separate, but instead interwoven in a dynamic, interconnected web, then our traditional ideas of causality and existence are called into question. It challenges our understanding of time as a simple, linear progression, urging scientists and philosophers alike to explore how our perceptions of time shape our broader understanding of reality. What does it mean for existence itself if time can bend, loop, or even reverse? Furthermore, Einstein's theory of relativity continues to challenge our perceptions of time itself. By suggesting that time is not an unchanging absolute entity, but rather a flexible component of the universe, relativity has forced us to rethink everything from the nature of space to the origins of the universe. The notion that time and space are intertwined in a four-dimensional fabric, space-time, means that time cannot be viewed in isolation. It is forever linked to the three dimensions of space, with changes in one affecting the other. This understanding has profound implications for our search for the universe's origins, especially when we consider what happened before the Big Bang. According to the prevailing models of cosmology, if the universe began from an infinitely dense and hot singularity, traditional notions of time may no longer apply. Time, as we understand it, could have emerged only after the universe expanded and cooled, reshaping our entire conception of time's role in the cosmos. This idea challenges the very notion of before the Big Bang, because under Einstein's framework, time itself may have originated with the universe. In this sense, the Big Bang might not have been a mere event within time, but the very birth of time itself. The implications of these ideas are immense. They force us to rethink our understanding of the universe's beginnings, challenging long-held beliefs about causality, time, and existence. As we continue to probe the depths of cosmic phenomena, including dark energy, we are confronted not only with scientific puzzles, but also with deep philosophical questions about the very nature of reality. The more we explore these mysteries, the more we realize that the universe is far more complex and mysterious than we ever imagined, and our understanding of time may be the key to unlocking its deepest secrets. However, certain theoretical perspectives suggest that time might possess an essence of its own, independent of the space it accompanies. For instance, in quantum mechanics, there are interpretations where time is viewed not merely as a byproduct of cosmic events, but as a more fundamental, intrinsic aspect of reality. This concept takes the idea further, proposing that time could have even existed before the very structure of space itself came into being. Such an idea carries profound implications for understanding the origins of the universe. If time truly predated the emergence of space, it would suggest the possibility of a sequence of events, of states or conditions, that led to the universe's birth, as described in the Big Bang theory. According to this theory, roughly 8 billion years ago, the universe began from a state of unimaginable heat and density. It is this cataclysmic event that marks the origin of not just matter and energy, but time and space as we know them. In this sense, if time existed before the formation of the material universe, it could imply a reality far beyond our comprehension, a realm where even the fundamental laws of causality might not hold as we know them. These speculations about time before space unfold a cascade of further questions. Can we even imagine a time without space? What did time signify before the birth of stars, planets, or the very concept of the universe itself? Engaging with these mysteries doesn't just deepen our understanding of the cosmos' origins, it also challenges the core of how we perceive time itself. What are the true parameters of this force we call time? How can we fathom its nature if it existed in some form before the existence of everything we perceive as reality? These are the kinds of questions that invite us to probe the universe's birth, pondering the very essence of time and the laws that shape its unfolding. The Big Bang theory offers a detailed account of how the universe came into being. According to this theory, around 13.8 billion years ago, the universe emerged from an extremely hot and dense singularity, eventually expanding to what we see today. This singular event did more than create matter and energy. It gave birth to time and space themselves. Before the Big Bang, the concepts of time and space, as we currently understand them, simply didn't exist in any recognizable form. They were bound to the structure of the universe itself. As the universe began to expand, it cooled. From this chaos emerged the first particles, which eventually coalesced into atoms, stars, and galaxies. This progression demonstrates a deeply connected concept. Time is intimately tied to the expansion and evolution of the universe. As space expanded, time became the continuous measure of events unfolding within it. In essence, time itself began at the moment the universe started to expand. Each passing moment became a reflection of the universe's growth, marking the development of cosmic structures over billions of years. Another compelling aspect of the Big Bang Theory is the theory of general relativity, formulated by Albert Einstein. According to general relativity, mass and energy have the power to curve the fabric of space-time, the four-dimensional matrix that combines the three dimensions of space with the one dimension of time. This curvature profoundly alters our view of the universe's expansion, not merely as a movement through an already existing space, but as the very expansion of space itself. This process suggests that time is also intricately woven into this cosmic tapestry, further linking the two in ways we are only beginning to understand. There are also theories that explore the quantum nature of the universe's earliest moments. Quantum fluctuations, the tiny fluctuations in energy that permeated the early universe, might have played a crucial role in the formation of the cosmos as we know it. This leads to speculative concepts such as the multiverse, the idea that our universe could be a brief, fleeting moment within a far larger and dynamic cosmic process. This perspective challenges us to view the Big Bang not merely as the beginning of everything we know, but as a window into what might lie beyond the borders of our current understanding of time and space. Time is undeniably central to our comprehension of the universe's expansion. It governs everything from the way we observe distant galaxies to how we interpret key cosmic events. The universe's expansion began with the Big Bang, approximately 13.8 billion years ago, and continues to unfold today. This ongoing expansion is evident in the observation of distant galaxies, which appear to be moving away from us. The relationship between their speed and distance is governed by a fundamental principle known as Hubble's law, highlighting the deep interconnection between time and space in our understanding of cosmic expansion. Our comprehension of time also leads us into the realm of the universe's age. By studying the rate of cosmic expansion through the redshift phenomenon, the shift in the light emitted by faraway galaxies, we can infer the duration of the universe's expansion. This knowledge not only allows us to estimate vast cosmic distances, but also provides insight into the evolution of cosmic structures over billions of years. The light from distant galaxies, when observed from Earth, acts as a cosmic time capsule, offering us a glimpse into the universe's past and illustrating how much it has changed since its inception. In the end, these ideas compel us to rethink what we know about time and space. The questions we explore are not just academic, they touch on the very foundation of our existence, prompting us to reconsider what is truly possible within the universe and how the mysteries of time and space unfold before us. The more we delve into these cosmic puzzles, the more we realize how much there is yet to learn about the deep, intricate laws that govern our universe. The nature of time itself has long been a subject of intrigue and uncertainty, with theories like Einstein's theory of relativity offering a glimpse into its true complexity. Contrary to the simplistic view that time is a fixed and unchanging entity, Einstein proposed that time is, in fact, dynamic, shifting in response to gravity and the velocity at which an object moves. This revolutionary insight opens a Pandora's box of new questions, particularly when applied to cosmological expansion. For instance, the very nature of the universe's expansion comes into question. Rather than expanding into an existing, unchanging space, the expansion might be tied directly to the way time itself behaves. As objects near the speed of light or move through strong gravitational fields, the flow of time itself can alter. This means that time may not unfold uniformly across the cosmos. In some regions, it could stretch or compress in ways that challenge our conventional understanding. Such a realization pushes the boundaries of not just cosmology, but also our broader philosophical reflections on existence. If time can behave differently depending on location, does this suggest that time itself is an integral part of the universe's fabric? What does it mean for time to be infinite, or even to have had a true beginning? These questions invite us to rethink our position in an ever-changing cosmos, where time's role is not simply a passive background, but an active, malleable force. Delving deeper into these ideas, one encounters the groundbreaking theory of loop quantum gravity. This approach reshapes our understanding of both time and space, particularly when we examine conditions preceding the Big Bang. Traditional models treat space and time as a continuous continuum, but loop quantum gravity challenges this by suggesting that both space and time may be composed of discrete, quantized units. To visualize this, imagine the structure of space as a vast, intricate tapestry. Instead of smooth, continuous threads, the fabric is woven from tiny, looping structures that interconnect in a vast cosmic network. These loops form the very foundation of reality, and when we turn our gaze to the earliest moments of the universe, loop quantum gravity presents a startling idea. The universe may not have exploded from a singularity as previously believed. Rather than a singular Big Bang event, this theory hints at a cyclical universe, one that undergoes continuous cycles of expansion and contraction. If time itself behaved differently in the pre-Big Bang era, the so-called beginning of time may not be a true origin, but merely a transition between one cosmic phase and another. This concept challenges the notion of a linear, forward-moving timeline and introduces a more intricate view of cosmic evolution. It also brings quantum gravitational effects into the picture, implying that the physics of space and time could have operated under entirely different principles before the Big Bang, laying the foundation for a universe that is not a static creation, but rather a dynamic, evolving entity. Furthermore, if space and time are indeed quantized, this has far-reaching implications not just for our understanding of cosmic origins, but for the very nature of reality itself. We are prompted to reconsider everything from the beginning of the universe to the fabric of existence, questioning whether the universe is a linear progression or a vast, interwoven network of states influencing each other across an infinite timeline. This brings us face to face with profound philosophical dilemmas. If the universe has no definitive starting point but is part of an eternal cycle, what does that mean for our perception of time? How do we comprehend a universe where space and time are not continuous and unchanging, but dynamic and fluctuating? The philosophical implications of these scientific theories run deep. Time has long been viewed as a key pillar of existence, often understood as a linear progression, a sequence of moments stretching from past to future. Thinkers like Immanuel Kant propose that time is not an objective reality, but rather an inherent part of human consciousness. Time, in this view, is a structure our minds impose on the world in order to understand and navigate it. Does this imply that time, as we perceive it, is a construct, something that exists only within the confines of our experience, not as an external, independent force? In science, particularly in cosmology, this inquiry intersects with profound questions about the origins of the universe and the nature of time itself. Traditional models suggest that time began with the Big Bang, around 13.8 billion years ago. But if time emerged from this singular event, what does it mean for anything that happened before it? If time is intrinsically tied to the universe's existence, does it even make sense to ask what existed before time began? The scientific search for answers often leads to increasingly strange and esoteric realms where the boundaries between time, space, and gravity become blurred. Theories like quantum gravity and the multiverse suggest that the universe we inhabit may be only one of many, and that time itself may not be the unyielding linear force we imagine it to be. These concepts invite us to rethink the very nature of time, challenging our assumptions not just about the beginning of the universe, but about the very framework in which we experience reality. Are we capable of fully comprehending the primordial conditions of the cosmos, or are we bound by the limits of our cognitive frameworks, both scientific and philosophical? These questions challenge us to re-examine not only the origins of the universe, but also the deep mysteries of time itself. Can we truly know what came before the Big Bang, or are we forever constrained by the limitations of our perception and understanding? As scientists strive to uncover the hidden structure of the universe, philosophers urge us to reflect on the nature of our own experiences. The dialogue between science and philosophy enriches our understanding, offering us a deeper, more nuanced view of time. It invites us to question not only what happened before the universe as we know it came into being, but also how we experience and interpret time in our everyday lives. Pondering the concept of pre-universal time invites us to confront the very nature of existence itself. When we consider the beginning of the universe, we typically reference the Big Bang, a moment approximately 13.8 billion years ago when both space and time as we know them began. But what existed before this event? Did time even exist in a form we can comprehend? This question stretches the boundaries of human understanding, urging us to confront the limits of what we can truly know about the cosmos. Reflecting on the idea of beginnings and ends shapes our worldview in profound ways. We often think of life in terms of milestones: birth, growth, achievement, and eventually death. These stages form the framework within which we understand our existence, offering a linear trajectory that helps us make sense of our place in the world. Yet, as we delve deeper into the cosmos and the nature of time, we are forced to confront the possibility that the universe itself might not follow this linear pattern. Instead, it may be a complex, cyclical process, with no true beginning or end, but an ever-evolving flow that transcends the limits of our human perception. However, when we contemplate a time before the universe, the linear perspective that governs our understanding of existence begins to blur. It presents a profound challenge to the very concept of time itself. Time, as we know it, may not be a constant or an absolute force, but rather a construct that comes into being with the universe. This radical idea forces us to rethink our relationship with time. If time itself began with the birth of the universe, then what does it mean to think of time as a cyclical phenomenon, or as something that exists outside of our comprehension? What then is infinity? And could there be a form of eternal existence that transcends the boundaries of our universe? These questions push us to reconsider the very foundations of reality. Our traditional notions of beginnings and ends, ideas that are deeply rooted in human experience, may be nothing more than illusions. For humanity, we are tethered to this temporal cycle that defines much of our lives, yet the universe may have a different narrative altogether. This notion of cyclical time challenges the fundamental understanding of birth, existence, and the endless expanse of reality. It invites a reimagining of our entire worldview, shifting away from a simple past and future dichotomy into a broader, more philosophical and scientific meditation. Each step we take in peeling back the layers of this vast mystery reveals deeper complexities, forcing us to rethink not only our understanding of time, but also the very nature of existence itself. As we confront these uncertainties, we cannot help but feel both awe and humility. The more we explore, the more questions arise, urging us to continue our quest for answers. Answers that stretch the limits of human knowledge and touch on the deepest mysteries of the cosmos. The story of our cosmic origins is not confined to scientific research, laboratories, or the sterile environment of observatories. It resonates throughout human culture and belief systems across the globe. From ancient cosmologies to cutting-edge scientific theories, the question of how the universe began has had a profound influence on our understanding of existence, purpose, and our place within the vast expanse of the cosmos. Throughout history, different cultures have spun myths and stories to explain the mysteries of the heavens. These stories were not just reflections of astronomical phenomena, but also reflections of deeper philosophical truths, often serving as the backbone of religious and spiritual belief systems. For thousands of years, these cultural narratives have shaped the way people perceive the universe. And in many of the world's religions, the creation of the universe is depicted as a divine act. Take, for example, the Judeo-Christian tradition, where the book of Genesis tells the story of a purposeful creation by a singular, omnipotent God. This story offers much more than a historical account of the universe's beginnings. It instills a sense of order and meaning in the world, grounding ethical principles and strengthening community bonds. In Hindu cosmology, the universe is viewed as a series of cyclical processes, cycles of creation and destruction, that reflect a cosmic rhythm that governs not only the physical world, but also our understanding of existence, time, and the divine. These cycles offer followers a framework for contemplating life and the universe's deeper mysteries. Such interpretations provide comfort, structure, and guidance, giving people tools to navigate the complexities of life and existence. These ancient stories were not simply myths. They were vital frameworks that shaped the values, ethics, and social structures of entire civilizations. Even today, these cosmological narratives continue to provide a sense of purpose and connection to something larger than ourselves, offering solace amid the vastness of an often bewildering universe. In the modern era, the advent of scientific theories, particularly the Big Bang Theory, has radically reshaped how we understand the universe's origins. Grounded in empirical evidence and sophisticated mathematical models, these scientific theories offer a picture of the universe that is far removed from the religious or mythological stories of the past. Yet, while these theories have deepened our understanding of cosmic processes, they also present profound philosophical and existential questions. For some, the complexity and scale of the universe evoke a sense of awe and wonder, our tiny, fragile existence amidst the vastness of space and time. For others, the purely scientific perspective raises questions that challenge traditional beliefs, prompting debates about the intersection of science, spirituality, and the very nature of existence itself. This ongoing interplay between science and cultural belief systems continues to evolve, especially as technological advances push the boundaries of what we can observe. With the advent of more powerful telescopes, humanity now peers into the furthest reaches of space, unearthing new evidence that not only deepens our understanding of the cosmos, but also sparks new questions. As we uncover more about the universe's beginnings, each new revelation can change our cultural narratives, shaping new philosophies and belief systems. With each discovery, humanity is confronted not only with new facts, but also with new interpretations of those facts. Interpretations that continue to evolve, often radically altering the way we view ourselves in relation to the cosmos. Storytelling, both ancient and modern, serves as a bridge connecting humanity to the vast and often elusive concepts of the universe. Through stories, we give meaning to complex scientific ideas, making them accessible, relatable, and emotionally resonant. When we attempt to grasp the enormity of the cosmos, we face enormous scales, intricate phenomena, and profound mysteries, elements that seem beyond the limits of human comprehension. By embedding these scientific discoveries into stories, we transform abstract facts into experiences that touch our hearts and minds. These stories allow us to contemplate our existence in ways that are more personal and meaningful, weaving the threads of science, imagination, and emotion together. Throughout human history, the stars and planets have been seen not merely as celestial bodies, but as symbols imbued with meaning and purpose. In many cultures, the movements of the stars were believed to influence human affairs, guiding the actions of individuals and societies. These ancient myths and legends not only offered explanations for the workings of the heavens, but also evoked a sense of wonder, curiosity, and reverence for the cosmos. Whether through scientific exploration or mythological tales, these stories help us frame our inquiries into the universe and guide our search for meaning and understanding. They prompt us to ask the essential questions. Where do we come from? What does it mean to be human in this vast and ever-expanding universe? In the world of science communication, storytelling plays a pivotal role in bridging the gap between complex discoveries and public understanding. Scientists often transform their intricate findings into compelling narratives, making the unknown more approachable and accessible to a wider audience. When advanced astrophysical concepts such as black holes, dark matter, or the origins of the universe are framed within a narrative, they become not just abstract ideas, but parts of a greater story that resonates with people on a personal level. This storytelling approach invites the audience to step into the ongoing quest for knowledge, transforming them from passive observers into active participants in the exploration of the cosmos. Such a narrative framework does more than simply convey information. It encourages people to connect emotionally with the subject matter. The complex world of astrophysics, often perceived as distant and difficult, suddenly becomes something people can relate to. When we explore the vast mysteries of space through storytelling, we begin to engage with them on a deeper, more human level, grappling not only with scientific facts, but also with our own fears, dreams, and aspirations. In the vastness of the universe, we seek meaning and purpose, attempting to find our place amid the chaos of existence. Storytelling thus transcends its role as mere entertainment. It becomes an essential tool for understanding the universe and our place within it, offering us a way to interpret and make sense of the overwhelming complexity that surrounds us. Through stories, we come to understand that the universe is not just a cold, indifferent expanse, but a place of wonder that holds the potential to reshape our understanding of life itself. Every new discovery in cosmology adds layers to this narrative, urging us to reconsider long-held beliefs about existence and our role in the grand scheme of things. As we continue to uncover the secrets of the cosmos, from the colossal scale of the universe to the enigmatic nature of black holes, we gain insights that challenge our assumptions about life and our purpose. With each breakthrough, we see the boundaries of our traditional narratives stretch and expand, inviting us to rethink not just the cosmos, but ourselves. Take, for instance, the study of the origins of the universe, especially through the lens of the Big Bang Theory. As we explore how the universe came to be, we begin to see ourselves not as isolated beings on a tiny speck of dust, but as part of a vast, interconnected web of matter and energy. The realization that our planet is just one small fragment in the immense expanse of space can be a humbling experience. It serves as a reminder of our fragility and the interconnectedness of all things. This perspective fosters a sense of unity, where humanity is no longer seen as separate from the cosmos, but as an integral part of a greater whole. Furthermore, imagine the possibility that life exists beyond Earth. Such a discovery would not only spark immense curiosity about extraterrestrial civilizations, but also force us to confront profound existential questions. How does the existence of life elsewhere change our understanding of ourselves? What does it mean to be human in a universe that may be teeming with life and unknown wonders? The pursuit of these answers could ignite a collective desire to seek knowledge, prompting us to reflect on our shared humanity and our place in the grand cosmic story. Ultimately, the power of storytelling in science is its ability to transform the abstract into the tangible, making complex concepts not only understandable, but deeply meaningful. As we continue to explore the far reaches of space and the fundamental nature of reality, storytelling provides a pathway to understanding the universe that is both intellectual and emotional. It fosters a deeper connection to the cosmos, allowing us to see beyond the stars and into the very heart of what it means to be alive in this vast, mysterious universe. Through these stories, we are reminded that the journey of discovery is not just about gathering facts, but about exploring the deeper truths of existence itself. Moreover, as advancements in cosmology push the very limits of our understanding, they not only alter our perception of time, space, and reality, but also spark deep philosophical debates that transcend centuries of human thought. These new discoveries invite us to reconsider ancient ideas, concepts once deemed to belong only to myth or speculation, yet now increasingly pertinent in light of modern science. As we explore the possibility of multiverses or alternate dimensions, we are prompted to confront profound questions about fate, destiny, and free will. Suddenly, the conventional frameworks through which we have viewed existence begin to fragment and reshape, offering us an opportunity to reconsider our purpose within this ever-expanding cosmos. In this ever-deepening journey into the mysteries of the universe, we are invited to go beyond the limits of spiritual and religious interpretations. As our knowledge of the cosmos expands, we are drawn into a larger contemplation, not only about where we come from, but also where we are headed. The implications of such monumental discoveries are far-reaching, often igniting societal movements toward a renewed reverence for science, philosophy, and even art. These disciplines, so often treated as distinct, merge as we seek to understand our place in the grand narrative of the universe. What is truly remarkable about these advancements is their ability to inspire awe, turning once abstract concepts into tangible sources of reflection. The pursuit of knowledge transforms into a pathway that allows us to examine life, existence, and our interconnection to everything that surrounds us. It compels us to ask not just intellectual questions, but also personal ones as we search for meaning in the vastness of space. Throughout the history of human thought, various cultures have created rich, intricate tapestries of belief and narrative about the cosmos, its beginnings, its workings, and its inevitable end. Ancient civilizations looked to the skies, finding meaning and direction in celestial events. For instance, many indigenous cultures of North America crafted creation myths that spoke of a great spirit or a trickster figure who was responsible for shaping the world. These narratives emphasize not only the interconnectedness of all life, but also how humans can live in harmony with nature. The idea that we are all intrinsically linked to the world around us offers a sense of purpose and belonging within the natural order. In contrast, the ancient Egyptians had their own unique vision of creation, which involved the god Atum rising from the primordial waters to create the first divine beings. This creation story ultimately gave rise to the cycles of life, death, and rebirth, mirrored in the daily journey of the sun across the sky. It was a powerful symbol of life's enduring nature and the eternal renewal of existence. Similarly, Hindu cosmology offers a stunningly intricate vision of time as cyclical, with the universe undergoing perpetual cycles of creation, preservation, and dissolution. The unceasing rhythm of this cycle offers profound insights into human existence, underscoring both the transient nature of life and the endless cycles of transformation that shape the universe. Western religious traditions, such as Christianity and Islam, also grapple with notions of finality and the end of existence. Christianity, for instance, speaks of the apocalypse, a time of transformation and ultimate judgment, marking the final chapter in the human story. Islam, too, presents the Day of Judgment, which signifies a pivotal moment where humanity's fate will be sealed. These ideas, whether framed as a divine reckoning or an existential transformation, speak to humanity's collective search for meaning in a world that seems at times chaotic and unpredictable. As modern science progresses, it begins to harmonize with these ancient perspectives, offering a new framework to understand the universe. The Big Bang Theory, for instance, proposes a cosmic beginning around 13.8 billion years ago, offering a scientific explanation of how the universe came into being. Similarly, theories about the eventual fate of the universe, whether it's a heat death or a dramatic big crunch, mirror age-old concerns about the end of all things. In this way, the intersection of science and culture creates an ongoing dialogue, one that bridges ancient myths and modern discoveries, uniting humanity in a shared quest to understand our origins and our ultimate destinies. One of the most mind-boggling modern theories, the concept of a multiverse, expands our understanding of reality in profound ways. It suggests that multiple universes may exist, each governed by its own physical laws and history. This idea challenges our traditional notions of identity, prompting us to reconsider what it means to be an individual. In a multiverse, there may be countless versions of ourselves, each making different decisions and leading distinct lives. The implications are vast. Are we defined by our choices, or do we possess a deeper, more unchangeable essence? Philosophers have long wrestled with questions about existence, what it means to live a meaningful life, and how our choices shape our identity. In a multiverse, where every possible decision could materialize in some parallel universe, it might seem that the stakes of our actions are diminished. If every possible version of ourselves is realized somewhere in the vastness of the multiverse, does that mean our individual choices don't matter? This thought could provoke existential dread for some, as they wonder whether their lives have any true significance. On the other hand, it could also offer a liberating perspective. If every possibility is played out, then each individual life, along with its unique lessons and consequences, gains its own intrinsic value. Moreover, exploring the implications of a multiverse leads to deeper philosophical discussions about fate, free will, and responsibility. If other versions of ourselves exist in different universes, making different decisions, what does this mean for our understanding of accountability? Are we simply products of our circumstances, or do we have the agency to shape our identities and destinies, even across multiple realities? These questions push the boundaries of philosophical inquiry, challenging us to reconcile our innate sense of self with a reality that resists singularity and embraces infinite possibilities. Ultimately, the idea of the multiverse presents a tantalizing framework to explore the intersections of science and philosophy. It encourages dialogue about identity, the nature of existence, and the choices that define our lives. These conversations enrich our understanding of humanity, fostering a greater appreciation for the complexity and depth of life itself. They invite us to reflect on what it truly means to be who we are in a universe or multiverse that is potentially infinite, filled with an infinite number of possibilities. Scientific discoveries about the origins of the universe have a unique way of intersecting with spiritual beliefs, sparking conversations that bridge the gap between the empirical and the transcendent. When scientists present insights into how the universe began, such as through the Big Bang Theory, they offer a narrative of cosmic evolution that resonates with believers and thinkers alike. This shared wonder about the mysteries of life, whether through the vastness of space or the intricate beauty of nature, brings science and spirituality into a common space, offering us both scientific and theological perspectives that enrich one another. For many, the idea that everything in existence began from a singular moment in time strikes a deep chord. It mirrors creation stories found in spiritual traditions across the globe, each describing a transformative event or divine creator who brings order from chaos. This idea parallels the scientific notion of an initial explosion of energy and matter, an event that ultimately gave birth to galaxies, stars, and planets. The confluence of these perspectives provides a richer, more layered understanding of our existence, one that allows us to contemplate life not only from a scientific standpoint, but from a deeply spiritual one. In this ongoing dialogue between science and spirituality, each viewpoint enhances the other, enriching our collective quest to understand the nature of existence itself. Cosmic discoveries, such as the presence of cosmic radiation and the growing evidence of expanding galaxies, inevitably raise profound questions about our place in the universe. These revelations about the vastness of the cosmos stir existential reflection, prompting us to consider the purpose of life within the grand scheme of the universe. As scientific advancements shed light on the laws that govern celestial bodies, the fundamental forces shaping our reality, and the intricate structure of the universe, spiritual seekers find themselves drawn into a deeper contemplation of what it truly means to be part of such a complex grand design. In moments where scientific understanding intersects with spiritual inquiry, a dialogue naturally unfolds. This intersection fosters mutual respect and curiosity as each discipline offers a unique approach to answering some of humanity's most fundamental questions. What is our origin? What is our purpose? What is our place in existence? This cross-pollination of ideas creates a rich, interconnected tapestry of thought, blending both the scientific and the spiritual. It is through these reflections that we find ourselves not only more connected to the universe around us, but also to each other. These intersections challenge us to look more closely at our own beliefs and embrace the mysteries of life in a way that encourages deeper introspection. As we expand our understanding of the cosmos, we are also prompted to reflect on our individual existence and collective purpose. It is through this exploration that we may come closer to uncovering the deeper meaning of life itself. Educational institutions, with their critical role in shaping our understanding of the universe, play a pivotal part in bridging the gap between complex cosmological theories and public comprehension. Universities offer structured curricula that allow students to dive into the intricacies of cosmology, providing them with the scientific framework necessary to comprehend the universe's origins, structure, and ultimate fate. Through these programs, students are encouraged to approach cosmology with a critical eye, engaging with contemporary debates about phenomena such as dark matter, cosmic inflation, and the ever-expanding nature of the universe. These discussions challenge conventional perceptions of reality, pushing the boundaries of what we think we know. But education does not stop in the classroom. Many institutions actively engage in outreach programs that aim to demystify the field of cosmology for a broader audience. Public lectures, science festivals, and planetarium shows, often featuring distinguished astronomers and physicists, serve to present complex ideas in an accessible manner. By offering these events, universities and research centers allow the public to grasp even the most intricate scientific theories. The goal is not just to educate, but to inspire curiosity and spark a collective interest in the cosmos. Moreover, research centers and observatories provide opportunities for public engagement through hands-on initiatives like workshops and citizen science projects. These programs invite individuals to contribute directly to cosmological research, whether by making observations, assisting with data analysis, or tracking celestial events. This participatory approach not only fosters a deeper appreciation of the science, but also empowers individuals to critically engage with the universe they inhabit, allowing them to become active participants in the ongoing exploration of the cosmos. As cosmological discoveries continue to shape our understanding of the universe, institutions are increasingly recognizing the ethical implications of these findings. Discussions surrounding the impact of astronomical research and technology on society are now more prevalent in academic settings. By addressing these ethical dimensions, educational institutions ensure that the pursuit of knowledge about the universe is balanced with reflection on our responsibilities here on Earth. This holistic approach to education encourages us to consider how our understanding of the cosmos influences our behavior, values, and priorities on a global scale. In weaving together the complex threads of cosmology, ethics, and public engagement, educational frameworks cultivate a society that is not merely informed, but also actively engaged in the grand narrative of the universe. This interplay between science, ethics, and public involvement forms the backbone of a society that is not only curious about the cosmos, but committed to navigating the challenges and questions it presents. The relationship between futurism, fiction, and scientific exploration also adds another layer to our understanding of the universe. Fictional narratives, particularly in literature and cinema, often act as mirrors, reflecting and amplifying our evolving understanding of reality. As scientific theories advance, particularly in the realms of physics and cosmology, storytellers have increasingly incorporated new ideas about time, space, and the nature of existence into their works. This intersection of science and imagination offers a unique lens through which to explore the implications of scientific discovery. At the dawn of the 20th century, the advent of Einstein's theory of relativity sparked new avenues for writers to explore concepts such as time travel and the warping of space. H.G. Wells, for example, captured the imagination of readers with his novel The Time Machine, in which time is introduced as a fourth dimension. This concept not only challenged traditional views of time, but also inspired future generations of scientists and storytellers to question how we might traverse time and space. The scientific theory itself became a fertile ground for creative exploration, inviting thinkers and creators to imagine what lay beyond the boundaries of our understanding. As the 20th century progressed and quantum mechanics and the multiverse theory began to take shape, speculative fiction experienced a renaissance. Writers such as Philip K. Dick posed profound questions about reality and identity, suggesting that the cosmos might contain countless parallel worlds, each slightly different from our own. Films like The Matrix explored these themes, presenting narratives of simulated realities and the nature of consciousness, underpinned by subtle interpretations of scientific principles. These stories not only entertained, but compelled audiences to reflect on their own existence, free will, and the very fabric of the universe. Today, as scientific breakthroughs continue to unfold, futurism continues to evolve. Emerging technologies such as artificial intelligence, space travel, and genetic engineering have become central themes in speculative fiction, generating new narratives that explore the ethical challenges and speculative futures that lie ahead. The exchange between science and fiction remains dynamic, with each feeding into and influencing the other. As new discoveries are made, fiction offers a canvas on which to explore what is possible, while simultaneously shaping the public's perception of what the future may hold. One of the most fascinating concepts emerging from contemporary cosmology is the cyclical model of the universe, which invites us to rethink our understanding of existence, life, and death. Traditionally, many cultures have viewed life as a linear journey, marked by distinct beginnings and endings, where life emerges, flourishes, and eventually ceases. However, cyclical models challenge this worldview, proposing that the universe may be in a perpetual state of birth, death, and rebirth, and inviting us to reconsider the nature of time, existence, and our place within it. This concept opens up profound questions about the nature of life, death, and the possibility of eternal recurrence, suggesting that our understanding of reality may be far more fluid and expansive than we ever imagined. In embracing these evolving scientific ideas and philosophical reflections, we continue to expand our understanding of the cosmos and our place within it. The journey of discovery is one that not only enhances our knowledge, but encourages us to reflect on our deeper connection to the universe, to life, and to each other. However, cyclical models of the universe introduce a fascinating and thought-provoking perspective on the nature of existence, one that suggests the cosmos is not a singular event with a definite beginning and end. Instead, it proposes that the universe undergoes infinite cycles of creation, destruction, and rebirth. With each cycle, new stars, planets, and galaxies emerge, flourishing in their unique way, only to eventually collapse back into a singularity, a point of infinite density, where all matter and energy are concentrated. From this singularity, the process may once again begin anew, giving birth to another cycle of existence. This perspective challenges the conventional view of finality and death, suggesting that the end of one cycle does not necessarily mark an absolute conclusion, but instead points to a transformation or transition into another phase. In this grand cyclical process, life and death are not permanent markers of existence, but rather integral parts of an ongoing, infinite rhythm. For individuals, this model redefines death, not as a definitive end, but as a passage, an inevitable yet temporary stage in an unbroken continuum of existence. It offers a sense of continuity, one that can alleviate some of the existential burden we place on mortality. By adopting a cyclical worldview, we can begin to see life not as a series of isolated events, but as part of an intricate, interconnected tapestry. The recognition that our experiences contribute to a greater cosmic pattern can instill in us a deeper sense of connection to the universe. It can also lead to a more profound appreciation for the present moment, encouraging us to value our actions, relationships, and choices as vital threads woven into this eternal cycle. In this light, our legacies are not confined to the limited span of our own lifetimes. They may ripple out, persisting in the ongoing rhythm of existence long after we have passed. This shift in perspective nurtures a sense of purpose, a feeling of belonging to the cosmos and to the web of life on Earth, which continues to unfold in a timeless dance. Embracing the idea of cyclical existence also reshapes how we respond to change, be it personal, societal, or cosmic. Instead of seeing the inevitable shifts and transitions of life as mere endings, we may come to recognize them as the beginnings of something new. The cyclical nature of the universe encourages us to engage with life more fully, accepting the flow of both creation and destruction with grace. This perspective nurtures a more harmonious relationship with the impermanence of existence, allowing us to focus not just on the closures of chapters, but also on the new beginnings that emerge from them. At the same time, the relationship between empirical science and philosophical inquiry opens up rich avenues for understanding the origins and structure of the universe. Empirical science, grounded in observation, experimentation, and data, provides concrete insights into the physical phenomena that shape the cosmos. Through disciplines like astrophysics and cosmology, scientists probe the depths of space, exploring phenomena like cosmic microwave background radiation, the expansion of the universe, and the formation of galaxies. These observations have led to widely accepted models, such as the Big Bang Theory, which offers a framework for understanding the universe's evolution based on measurable, quantifiable evidence. Yet, while empirical science offers explanations rooted in data, philosophical inquiry delves into questions that often transcend the bounds of what can be directly observed. It engages with abstract concepts like causality, existence, and the very nature of time itself, questions that remain elusive to scientific measurement. For example, philosophers ponder whether the universe had a true beginning or if it has existed eternally in some form. They question the very notion of beginning, a concept often tied to time as we understand it. What does it mean for something to begin? What does it mean for one event to cause another? These profound inquiries not only challenge the assumptions behind scientific models, but also push the boundaries of human understanding. The relationship between empirical science and philosophy is not one of opposition, but rather of symbiosis. Each discipline informs the other, fostering a richer dialogue that deepens our grasp of the cosmos. Scientific discoveries often spark new philosophical questions, and philosophical discussions can lead to new scientific explorations. One notable example of this interplay is the concept of the multiverse, the idea that our universe is one of many interconnected universes, each existing in parallel to one another. While this notion has its roots in scientific theories, its implications for reality and existence stretch into deep philosophical territories. Ultimately, the collaboration between empirical science and philosophical thought enriches our collective understanding of the universe. By blending the hard evidence of science with the deep questions raised by philosophy, we can form a more complete picture of not only how the universe came to be, but also why it exists in the first place. This synthesis encourages us to move beyond the limitations of individual disciplines and explore the vast, uncharted territory that lies at the intersection of knowledge and inquiry. Philosophical thought plays a crucial role in framing the scientific questions surrounding the origins of the universe, particularly when it comes to understanding events that occurred before the moment commonly referred to as the Big Bang. The Big Bang is often seen as the pivotal moment in the history of the cosmos, the instant when space and time, as we know them, began to unfold. But the deeper we probe into the origins of the universe, the more we encounter fundamental questions about existence itself. Concepts like causality, the nature of time, and the very possibility of before and after become increasingly complex. If time itself began with the Big Bang, how can we even talk about what came before? This paradox is where philosophy becomes indispensable. Philosophical inquiry aids scientists in untangling these profound dilemmas, offering frameworks for understanding the assumptions we make about time and existence. For instance, philosophers like Immanuel Kant have argued that time, as we experience it, is not an inherent property of the universe, but a construct of human cognition. Such insights can inspire scientific hypotheses about the state of the universe before its inception, offering novel avenues for exploration and discovery. Moreover, the concept of causality, which underpins much of scientific thought, is deeply influenced by philosophical discourse. The classical view of causality, every effect having a cause, helps structure scientific inquiry. However, as scientists venture further into the mysteries of the cosmos, they are often confronted with scenarios where traditional ideas of cause and effect may no longer apply. Through this dynamic relationship between empirical science and philosophical inquiry, we begin to see how our understanding of the universe is continuously evolving. Science provides the hard data that forms the foundation of our knowledge, while philosophy challenges us to question the very assumptions upon which that knowledge is built. Together, they create a deeper, more nuanced view of the cosmos, one that invites us to reconsider not only the origins of the universe, but the very nature of existence itself. Exploring the mysteries of the universe, especially its origins before the Big Bang, forces us to confront profound questions that stretch the limits of both science and philosophy. One of the most difficult inquiries to address is whether the universe requires a cause to exist or whether it could have emerged spontaneously without one. This question challenges not only the core paradigms of scientific understanding, but also opens the door for deeper interdisciplinary conversations. It compels scientists to consider possibilities that go beyond traditional physics, engaging in philosophical reflection to explore ideas that are often difficult to measure, observe, or even fully grasp. By incorporating philosophy, scientists enrich their work, embracing a broader spectrum of potential answers and encouraging more innovative and flexible approaches to scientific inquiry. The intersection of science and philosophy in the study of the cosmos allows for greater creativity in the exploration of theories. Concepts like the multiverse or quantum cosmology offer compelling possibilities, pushing the boundaries of what we know about reality. These philosophical frameworks help scientists move beyond empirical data to explore abstract, untested models that could reshape our understanding of the universe. The relationship between science and philosophy has proven to be not only beneficial, but essential as it challenges existing knowledge and encourages novel ways of thinking about the cosmos and its origins. Cosmology, as a scientific field, is grounded in empirical evidence, observations, data, and mathematical models that help us make sense of the universe's structure and history. The Big Bang Theory, for instance, provides a widely accepted explanation of the universe's origins. However, other models, such as the steady-state theory, offer alternative views. This ongoing rivalry exemplifies the dynamic tension between scientific inquiry and philosophical reflection, as each theory presents its own set of assumptions, challenges, and interpretations of the universe's beginnings. Scientific theories undergo constant testing and validation, with new discoveries leading to shifts in our understanding. But alongside this empirical process, the philosophical dimensions remain vital. Philosophers ask fundamental questions about the nature of time, existence, and the possibility of an infinite universe, concepts that cannot be easily quantified by measurement alone. As cosmology delves into abstract models like multiverses, suggesting the existence of multiple parallel universes, philosophical discourse becomes even more crucial. These ideas raise questions that go beyond the tangible limits of human observation, prompting us to consider the very nature of reality itself. How can we know or measure things beyond our universe? What are the implications of realities we cannot perceive or comprehend? These questions point to the limits of human understanding and challenge the foundational assumptions of both science and philosophy. In recent years, advancements in observational technology, such as more powerful telescopes and satellite missions, have continuously tested existing models, reshaping the philosophical dialogue around them. For instance, the discovery of dark matter and dark energy has forced both scientists and philosophers to reconsider the unseen components of the universe. These elusive phenomena, which make up much of the universe's mass energy content, have sparked debates about the nature of reality, the limits of our knowledge, and the very fabric of existence itself. Ultimately, the intersection of scientific discovery and philosophical interpretation forms a rich, evolving dialogue. Each competing theory contributes new insights, offering researchers a deeper understanding of the universe. Whether through mathematical models or philosophical musings, each inquiry helps push the boundaries of what we know, leading us closer to answers about the cosmos. It is within this ongoing collaboration, where ideas from both disciplines are constantly evolving, that our understanding of the universe's origins and our place within it grows ever more profound. The exploration of the universe's beginnings is perhaps the most profound intellectual endeavor humanity has ever embarked upon. It is a journey where science and philosophy meet and intermingle, creating a tapestry of ideas that stretches from the very foundations of physical evidence to the most abstract of existential questions. While scientists analyze empirical data, philosophers provide conceptual frameworks for interpreting the implications of these findings. The results of these combined efforts are a more holistic understanding of our universe, one that takes into account both the observable and the speculative. Cosmologists typically approach the mysteries of the universe's origins through the study of cosmic phenomena, such as the cosmic microwave background radiation, the faint afterglow of the Big Bang, as well as the distribution of galaxies and the expansion of space itself. These observations allow scientists to piece together a detailed timeline of cosmic evolution, shedding light on how matter and energy have evolved over billions of years. Yet, despite these advances, several questions remain unanswered. What existed before the Big Bang? What is the true nature of time, especially at the moment of the universe's inception? These questions remain beyond the reach of conventional scientific methods, and this is where philosophy steps in. Philosophers ask questions about the very nature of existence, causality, and time, ideas that cannot be measured by telescopes or particle accelerators. They ask whether it is even meaningful to talk about a before the Big Bang if time itself had no beginning. What does it mean for something to begin if time itself is part of the phenomenon we are trying to explain? These questions invite scientific inquiry to expand beyond its usual boundaries, fostering creative and speculative thinking about the universe's origins. When concepts like the multiverse are proposed, suggesting that our universe might be just one among an infinite number of parallel universes, philosophy plays a crucial role in exploring the deeper implications. Philosophers examine what these theories say about reality, existence, and probability, adding a layer of complexity to the scientific discourse. By contemplating the potential realities of multiverse theories, philosophers challenge us to rethink the meaning of existence and our place in the cosmos. This collaboration between science and philosophy does not merely enhance our understanding of the cosmos, it reshapes how we think about the world itself. As new technologies and theories emerge, both disciplines influence and inform each other, creating a dynamic, evolving feedback loop. The result is a deeper and richer understanding of the universe, a blend of hard data and abstract thought that moves us closer to solving one of humanity's greatest intellectual puzzles, the origins of everything. Scientific challenges and paradoxes also offer valuable insights into the nature of scientific inquiry. When theories fail or when new questions arise that do not fit neatly into established models, it can lead to breakthroughs. For instance, attempts to understand what preceded the Big Bang have opened up profound discussions on the nature of time, space, and causality. Traditional models of time as a linear progression break down when we try to account for a moment before time itself existed. This paradox has sparked theories like cyclical models of the universe or quantum mechanics, both of which challenge the idea of a singular starting point for the cosmos. Additionally, scientific exploration of quantum fluctuations, tiny random variations in energy, has been pivotal in understanding the rapid expansion of the universe during the first moments after the Big Bang. While quantum fluctuations provide a plausible mechanism for the birth of matter and energy, they also reveal gaps in our understanding. These gaps, however, serve as fertile ground for the development of new theories, such as the multiverse hypothesis or the exploration of dimensions beyond our own. Ultimately, the process of grappling with these paradoxes and failures pushes scientific inquiry forward, forcing us to refine our understanding of the universe and our place within it. By confronting what we do not yet understand, we allow for the emergence of new ideas, new technologies, and new methodologies. It is through these challenges that humanity's most profound discoveries are often made, as scientific failures lead to new ways of thinking and conceptualizing reality. When we engage with abstract philosophical ideas, we enter a space that may seem distant from the empirical methods of science. However, it is precisely in this intersection of the known and the unknown, of the empirical and the abstract, that our understanding of the universe grows richer and more complete. The dialogue between science and philosophy is not only an intellectual exercise, but a crucial element in humanity's quest to understand the most fundamental truths about existence itself. However, these two domains can intersect in ways that many might not initially expect. The relationship between philosophy and science is far from one-dimensional. In fact, many philosophical questions, particularly those regarding consciousness, morality, and knowledge, can be deeply explored through scientific inquiry. Over the years, scientists have begun to push the boundaries of philosophical thought by applying scientific methods to complex, abstract concepts, turning intangible ideas into testable, observable phenomena. For instance, consider the exploration of consciousness. Philosophers have long debated its nature, but recent advances in neuroscience and psychology have allowed us to explore consciousness from a biological perspective. Using sophisticated tools like functional magnetic resonance imaging, fMRI, scientists can observe the brain in action, tracking brain activity as thoughts, emotions, and memories emerge. These groundbreaking methods offer a glimpse into the inner workings of the human mind, presenting a fascinating intersection where science uncovers what philosophy has long theorized. In the realm of morality, the dialogue between science and philosophy becomes even more intriguing. For years, philosophers have deliberated on the foundations of ethical behavior, debating what constitutes right and wrong. Now, psychologists and neuroscientists have begun conducting experiments to understand how individuals make moral decisions. Using controlled studies, they investigate how social influences such as peer pressure or cultural background might shape our ethical judgments. By observing the decision-making processes of individuals from diverse backgrounds, researchers are able to provide empirical data on a topic traditionally relegated to philosophical discourse. This brings a measurable scientific dimension to philosophical debates, grounding them in real-world behavior and social dynamics. One way that abstract philosophical ideas are being tested scientifically is through the process of operationalization. This approach involves defining a broad, often intangible concept in a way that it can be measured and analyzed. Take happiness, for example, a concept that philosophers have debated for centuries. While happiness is notoriously difficult to define, scientists have created surveys and scales to measure well-being across different populations. By quantifying how happiness is experienced in various contexts and by diverse groups of people, researchers are able to provide valuable insights into what happiness truly means and how it can be understood across cultures and societies. In this way, researchers transform abstract philosophical concepts into tangible, measurable data, creating new pathways for exploration and understanding. By breaking down these complex ideas into specific attributes and observable behaviors, science offers the opportunity to gather empirical evidence, leading to new conversations and insights within both fields. Philosophy, often dwelling in the abstract and the speculative, can benefit from scientific methods that provide data and evidence, while science can gain from the rich theoretical frameworks that philosophy provides. Together, they form a dynamic partnership, one that pushes the boundaries of knowledge in new, exciting directions. Through this collaboration, questions about the nature of existence, morality, and the universe can be explored in ways that neither discipline could achieve on its own. The intersection between philosophy and science becomes even more evident when we consider the deep, existential questions that arise in the realm of cosmology. Scientific inquiries about the universe's origin, such as the Big Bang Theory, offer profound explanations about the physical mechanisms that brought our universe into being. Yet, philosophical inquiries ask more fundamental questions. Why does the universe exist at all? While science can offer theories and explanations about how the universe began, it cannot address the metaphysical question of why it exists in the first place. This existential question transcends scientific methods, probing into realms that empirical data and experimentation are not equipped to answer. Philosophy also challenges the scientific understanding of time, especially in the context of cosmology. In science, time is often treated as a dimension, much like space, and scientists regularly measure the age of the universe by tracking the movement of celestial bodies and the cosmic background radiation. But philosophers ask whether time itself is truly real, or whether it is merely a human construct, an idea we have developed to make sense of our existence. Scientific measurements rely on observable phenomena, but these philosophical questions prompt deeper reflections on whether time has a true beginning, or whether it extends infinitely in either direction. Such questions have profound implications on how we conceptualize the universe's lifespan and its ultimate fate. Another significant philosophical challenge in cosmology arises from the nature of observation itself. The cosmological principle, which posits that the universe is homogeneous and isotropic on large scales, suggests that our observations of the cosmos are representative of the whole universe. But philosophers question whether this assumption is valid. Can we truly know the nature of the entire universe from our limited vantage point on Earth? These philosophical inquiries raise doubts about the limitations and potential biases inherent in scientific methodologies, and whether there might be fundamental aspects of the universe that remain forever beyond human comprehension. One of the most mind-bending scientific theories to emerge in recent years is that of the multiverse, the idea that our universe might be only one of many, each with its own set of physical laws. While this theory challenges the boundaries of scientific reasoning, it also invites deep philosophical reflection. If multiple universes exist, what does this mean for our understanding of reality? How does the concept of existence itself change when we consider the possibility of parallel universes? Philosophers push these questions even further, asking what the implications of multiverse theories might mean for our metaphysical frameworks and our understanding of existence. While science can describe the mechanisms of the cosmos, philosophy helps us navigate the broader, often paradoxical implications of those scientific discoveries. As our scientific knowledge expands, so too does our ethical responsibility. Advances in cosmology and technology have sparked philosophical questions about our role in shaping the future of the universe. The possibility of creating or altering a universe, whether through theoretical physics or the development of advanced technologies, raises profound ethical dilemmas. What moral framework should guide our actions if we gain the ability to manipulate or create new realities? Should we prioritize the well-being of life forms that might emerge from such actions, or is there an ethical obligation to preserve the sanctity of an untouched universe? These ethical dilemmas grow even more complex when we consider the creation of artificial life or environments that mimic natural ecosystems. In such scenarios, the concept of duty toward other beings, both sentient and non-sentient, becomes crucial. If we possess the power to alter the very fabric of existence, how should we weigh the potential consequences of our actions? What moral principles should govern our decisions when we are no longer merely observers of the cosmos, but active participants in its creation and manipulation? These questions challenge us to consider not only the ethics of our actions in the present, but the long-term ramifications they may have for the future of life and the universe itself. Ultimately, as science continues to probe the depths of the cosmos and explore the fundamental nature of existence, philosophy remains an essential partner in this quest for knowledge. Together, they can inspire new ways of thinking, challenging us to consider the implications of what we know and pushing us to explore what lies beyond the limits of human comprehension. As we stand at the crossroads of scientific discovery and philosophical inquiry, we are invited to embark on a collaborative journey, one that promises to expand our understanding of both the universe and our place within it. The dialogue surrounding the artificial manipulation of the universe invites profound reflections on the nature of human evolution and our very identity as a species. What would it mean if we, as humans, had the ability to construct worlds that resemble our own, or even create entirely new realities? Such capabilities would challenge the fundamental understanding of existence itself. If we could design realities, would our essence remain tied to our origins, or could it be redefined by the worlds we build? These questions raise complex ethical dilemmas, opening a floodgate of moral considerations about our responsibilities and rights towards beings that might inhabit these artificially constructed worlds. As humanity's technological capabilities advance at an unprecedented pace, the intersection of philosophy, ethics, and cosmology has never been more pertinent. The growing ability to manipulate and create new universes not only pushes the boundaries of science, but also forces us to confront deeper questions about our place in the cosmos. Each discussion surrounding the creation and manipulation of the universe touches on core human values, ethical responsibilities, and the eternal quest to understand our significance in the vast expanse of existence. Engaging with these ideas sharpens our moral framework and challenges our perception of reality, encouraging us to reflect on the far-reaching implications of scientific progress. Historically, the evolution of scientific thought has been intricately woven with philosophical inquiry. For millennia, philosophers and scientists alike have grappled with fundamental questions about existence, the nature of knowledge, and the essence of reality itself. In ancient Greece, philosophers such as Plato and Aristotle laid the groundwork for the scientific method, while simultaneously shaping the philosophical frameworks that guided the exploration of the natural world. Plato's allegory of the cave, for instance, illustrates the difference between perception and reality, a concept that resonates through the ages as scientists strive to uncover the true nature of the universe. As we move through history, the Renaissance ushered in a remarkable era when philosophical skepticism transformed into empirical investigation. Thinkers like Francis Bacon emphasized the importance of observation and experimentation, which became the foundation for the scientific method. This shift represented a departure from reliance on dogma and tradition, heralding a new age of inquiry into the workings of the universe. The symbiotic relationship between philosophical thought and scientific discovery continued to evolve, with philosophers challenging the prevailing Aristotelian views of the cosmos. This intellectual tension led figures like Copernicus and Galileo to propose revolutionary ideas, including the heliocentric model, which permanently altered humanity's understanding of its place in the cosmos. The Enlightenment further deepened the relationship between science and philosophy. Luminaries like Isaac Newton synthesized scientific observations with mathematical principles, revealing a universe governed by rational laws. The integration of mathematics and philosophy spurred significant advancements in physics, with questions about causality and the nature of the universe prompting further exploration. Debates about determinism and free will further fueled the dialogue between science and philosophy, creating a rich tapestry of ideas that extended beyond the physical into the metaphysical. In the modern era, the relationship between science and philosophy continues to evolve in response to the complexities of new theories. Quantum mechanics, for instance, has posed questions about the nature of observation, the role of the observer, and the very fabric of reality. These ideas have ignited philosophical discourse, challenging traditional notions of what we understand about the world around us. As these two disciplines continue to intertwine, they form an unending cycle of inquiry, with each enriching the other in the shared pursuit of knowledge and understanding. As scientific innovations progress, our ability to explore the cosmos is transforming rapidly. One of the most exciting developments is in the field of gravitational wave astronomy, which allows us to detect ripples in space-time caused by cosmic events such as the collision of black holes or neutron stars. This cutting-edge technology provides unprecedented insight into the universe's early moments, revealing phenomena that are invisible to traditional telescopes. Gravitational waves are offering a new way to study the most violent and mysterious events in the cosmos, providing a deeper understanding of the processes that shape the universe's evolution. Alongside this, artificial intelligence is becoming an increasingly powerful tool in the field of astrophysics. By processing vast amounts of data from observatories and simulations, AI can detect patterns and anomalies that might elude human analysis. This capability is enhancing our ability to study cosmic background radiation and detect distant galaxies, allowing us to refine our understanding of the universe's formation and evolution. As machine learning techniques continue to advance, the potential for uncovering new astronomical phenomena is growing exponentially. The development of next-generation telescopes, such as the James Webb Space Telescope, is also set to revolutionize our understanding of the universe's origins. By observing in infrared wavelengths, the James Webb Telescope can peer through the dust clouds that obscure our view of distant cosmic events. This ability to observe in unprecedented detail promises to yield valuable insights into the formation of stars and galaxies, unveiling secrets about the early stages of the universe. These observations will provide critical data about the elemental processes that led to the visible universe, shedding light on the origins of the cosmos and the fundamental forces that continue to shape it today. In this ongoing pursuit of knowledge, each new discovery, whether through advanced technology or philosophical inquiry, invites us to reconsider our place in the universe. These endeavors not only expand our understanding of the cosmos, but also encourage us to explore the ethical and existential questions that arise as we push the boundaries of what is possible. The future of humanity's exploration of the universe is both exciting and daunting, filled with endless possibilities and challenges that will shape our collective destiny. Advancements in particle physics are fundamentally reshaping our understanding of the universe, especially through the use of large-scale facilities like the Large Hadron Collider, LHC. These scientific marvels are providing invaluable data about the fundamental particles and forces that govern the very fabric of existence. By delving deeper into these building blocks of reality, scientists are gaining insights into the conditions that existed just moments after the Big Bang. As these cutting-edge technologies and methodologies continue to evolve, they not only redefine how we explore the cosmos, but also deepen our understanding of humanity's place within it. The ongoing interaction between scientific discovery and technological innovation opens up new avenues for exploring the origins of the universe, ensuring that our journey through space remains filled with constant revelations. One of the most profound areas of research in particle physics revolves around the mysteries that existed prior to the Big Bang. Here, the study of fundamental particles and forces is believed to hold the key to understanding the true origins of the universe. For example, new particles and interactions detected in high-energy environments might offer glimpses into the conditions that could have existed before the universe's dramatic expansion. Theoretical frameworks such as string theory and loop quantum gravity propose that the Big Bang may not have been the absolute beginning of everything, but rather a transition from an earlier phase of existence. These ideas challenge conventional thinking and suggest that what we understand as the universe's birth could merely be a continuation of a larger cyclical reality. Particle physicists are investigating these ideas by exploring particle behavior at energies that have yet to be achieved by Earth-bound accelerators. The LHC stands at the forefront of these efforts, enabling scientists to recreate conditions similar to those that prevailed in the moments just after the Big Bang. By carefully analyzing these experiments, researchers can begin to speculate about what the universe may have looked like before it exploded into its current form. Additionally, the study of elusive phenomena like dark matter and dark energy is central to understanding the universe's early conditions. If current theories about dark matter hold true, interactions between these mysterious particles and visible matter could reveal hidden structures and dynamics that predate the Big Bang. This would provide tangible evidence of a universe rich in history long before its infamous expansion. High-energy cosmic events, such as gamma-ray bursts and the cosmic microwave background radiation, are also crucial to understanding the early universe. These phenomena, which date back to the infancy of the cosmos, offer important clues about the forces at play during the first few moments of existence. Some researchers suggest that the conditions found in these events may have set the stage for the Big Bang itself. As scientists continue to probe the behavior of particles under extreme conditions, the possibility of uncovering pieces of this enigmatic puzzle grows ever more likely. This research, driven by the search for answers to one of the most profound questions in existence, what came before the Big Bang, could change the way we perceive the origins of the cosmos. The study of the universe's infancy presents scientists with a series of fascinating and complex challenges. One of the most daunting obstacles is the sheer scale of time involved. The universe is approximately 13.8 billion years old, and to investigate its earliest moments, scientists must reach back in time to just a fraction of a second after the Big Bang. During this brief period, conditions were extreme, with temperatures and densities far beyond anything that can be replicated in a laboratory setting. These hostile conditions make it incredibly difficult to conduct experiments or even make direct observations. Furthermore, much of the universe's early period is shrouded in the haze of energy and radiation, known as the cosmic microwave background radiation epoch. Detecting remnants from this era requires highly sensitive equipment and sophisticated techniques to filter out the overwhelming background noise from our own galaxy and other distant cosmic sources. Instruments like space-based telescopes are designed to capture the faint traces of this primordial light, but they face significant challenges in doing so. Interference from cosmic radiation and the interference of our own galaxy's emissions can obscure the signals scientists are seeking. As a result, the process of obtaining reliable data from this era involves a great deal of uncertainty and sophisticated interpretation. Another substantial challenge comes from the need for more advanced theoretical models to explain the events that took place in these early moments. While existing theories, such as general relativity and quantum mechanics, have proven invaluable in many areas of physics, they often clash when applied to the extreme conditions of the early universe. The lack of a unified theory means that observations can sometimes contradict existing models, forcing scientists to continually revise and refine their approaches. A particularly complex aspect of this research is the formation of the universe's first stars and galaxies. Observational data drawn from vast distances often relates to a much younger universe, meaning what we observe today is not an exact replica of the original conditions, but a distorted snapshot influenced by billions of years of cosmic evolution. This makes it all the more difficult to gain an accurate understanding of the universe's earliest moments. With each new discovery, new questions arise, challenging the limits of our knowledge and expanding our understanding of the universe's early history. The mysteries surrounding the birth of the cosmos continue to evolve, highlighting the complexity and wonder of exploring such a profound and enigmatic domain. Recent breakthroughs in astrophysics have opened up new avenues of thought, challenging long-standing ideas about the nature of the universe's origins. For centuries, the prevailing theory was that the universe began from a singularity, a point of infinite density and temperature. This idea suggested that time itself began with the Big Bang, raising questions about what, if anything, existed before that monumental event. However, advances in observational tools have revealed phenomena that suggest a much more intricate picture. For example, the discovery of dark energy in the late 20th century, coupled with the acceleration of the universe's expansion, has led to new hypotheses about the universe's evolution. Some theories propose that rather than originating from a singular beginning, the universe may have gone through a series of expansions and contractions, known as the cyclic universe model. These new ideas about the cyclic nature of the cosmos raise intriguing possibilities about the universe's past and future. Could the universe be part of an eternal cycle, with each phase of expansion followed by a contraction? If so, the Big Bang might not have been a singular event, but rather one of many cycles that have played out over an incomprehensible span of time. The cyclic model challenges everything we thought we knew about the origins of the universe and forces scientists to reconsider the very nature of time and existence. As researchers continue to push the boundaries of our understanding, the interplay between technological advancements and groundbreaking discoveries promises to offer more answers and raise even more questions about the true origins of the universe. The mysteries of dark matter, dark energy, and the behavior of particles at extreme energies will continue to be at the forefront of scientific inquiry as we strive to unlock the secrets that lie hidden beneath the surface of reality. The journey to understand the universe's birth is far from over, and each new revelation takes us one step closer to answering some of the most profound questions of all. What came before the Big Bang? What forces and particles shaped the cosmos before the expansion that gave birth to our universe? Only time will tell, but one thing is certain: the quest for answers will continue to shape the future of science for generations to come. Advancements in the study of cosmic background radiation have revealed some truly astonishing insights into the early universe, offering us a glimpse of what our cosmos might have looked like just moments after the Big Bang. Fluctuations in the cosmic microwave background radiation, those faint remnants of the universe's infancy, hint at the possibility that there were earlier structures or events that we have yet to fully understand. These fluctuations provide tantalizing clues, suggesting that there may be more to the story of the universe's origin than we currently comprehend. Some researchers even entertain the possibility of multiverses, where our universe is only one of countless others, each governed by its own set of physical laws and conditions. As we examine these emerging hypotheses, we find ourselves at a profound crossroads. Here, traditional cosmology intersects with groundbreaking, unconventional ideas. Every new discovery unearths uncharted territory in our quest to understand the cosmos, raising questions that challenge the very core principles of theoretical physics. The deeper we delve into the cosmic puzzle, the more we realize that the narrative of our universe is not a static tale, but an evolving one. With every new piece of the puzzle, our understanding grows, painting a more intricate and multifaceted picture of the origins of the universe. One of the most mysterious and crucial forces shaping the evolution of our universe is dark energy. Accounting for approximately 70% of the cosmos, dark energy has been the driving force behind the accelerated expansion of the universe. This extraordinary phenomenon has only been observed over the past century, yet its impact is undeniable. Instead of galaxies slowing down and being pulled together by gravity, they are in fact speeding apart, moving away from one another at an ever-increasing rate. This suggests that dark energy is the dominant force in the cosmos, overpowering even gravity itself. In the earliest moments following the Big Bang, the universe underwent an incredibly rapid expansion, a process often referred to as cosmic inflation. As it cooled, matter began to clump together, and one might have expected the universe's expansion to slow down as gravity began to take hold. However, something extraordinary happened around 5 billion years ago. Dark energy began to exert its influence, causing the expansion to speed up rather than slow down. This shift fundamentally altered the trajectory of cosmic evolution, leading to the vast, ever-expanding universe, we observe today. The discovery of dark energy has opened up a myriad of questions about the future of the universe. Will galaxies continue to drift farther apart, leading to a cold, lonely cosmos? Or might dark energy itself change over time, allowing gravity to regain its dominance? These profound questions offer us a glimpse into the dynamic and ever-changing nature of the universe. As researchers continue to probe the mysteries of dark energy, these questions only grow more complex, prompting us to reconsider everything we thought we knew about the nature of the cosmos. Dark energy challenges our most fundamental concepts of physics and forces us to rethink long-held assumptions about the universe's past, present, and future. With each new discovery, it becomes increasingly clear that our understanding of the universe is still unfolding, revealing layers of complexity that we are only beginning to explore. In this context, the blending of art and science offers an entirely new perspective on the cosmos. Art, with its ability to evoke emotion and convey abstract ideas, has the power to transform complex scientific concepts into something more accessible and relatable. Artists, for instance, can depict cosmic phenomena like the birth of stars or the infinite expanse of space in ways that make these abstract ideas tangible and personal. Through their creations, they invite audiences to engage with the cosmos, not as a distant, incomprehensible entity, but as something that connects us all, something deeply human. On the other hand, science lends rigor and empirical methods to artistic exploration. By grounding their work in scientific research, artists are able to push the boundaries of how we represent and interpret the cosmos. This collaboration between scientists and artists has led to the creation of immersive installations that evoke the essence of space-time, helping us grasp the unfathomable scale of the universe in a deeply emotional way. These cross-disciplinary efforts turn raw data and research findings into compelling narratives that resonate with society, creating a bridge between the complex language of science and the universal language of art. Furthermore, this integration can spark curiosity in young minds. When future generations encounter the beauty and wonder of the universe through artistic expression, they are more likely to ask questions and pursue answers within the realm of science. This collaboration between art and science fosters a sense of wonder that transcends disciplinary boundaries, uniting people from all walks of life in a shared appreciation of the universe. It not only enhances public engagement with science, but also enriches our understanding of cosmic origins, blending the analytical with the creative and expanding the conversation in unexpected ways. Visualizations of cosmic phenomena have become an essential tool in making complex scientific theories more comprehensible. By transforming abstract concepts and large-scale data into compelling images, animations, and simulations, these visual aids make the otherwise incomprehensible more tangible. Take, for example, visual representations of black holes and gravitational waves. These phenomena, once purely theoretical, can now be seen in stunning detail, allowing the public and the scientific community alike to perceive and better understand the invisible forces that govern our universe. One of the most striking features of these visualizations is their ability to convey the vastness of space and time. The sheer scale of the universe, spanning billions of light years, can be nearly impossible to comprehend. But through visual models, we can transform this enormity into something more graspable, turning light years into relatable distances and making the enormity of the cosmos feel just a little more personal. These visualizations allow us to better appreciate how the universe evolved, from the explosive birth of the Big Bang to the intricate dance of galaxies, stars, and black holes. As our understanding of the universe continues to evolve, These artistic and scientific efforts are essential in making sense of the complexities that lie ahead. With every new discovery, we are one step closer to unraveling the mysteries of the cosmos, and these cross-disciplinary explorations will play a pivotal role in bridging the gap between the scientific and the personal. In the end, it is through this synthesis of inquiry and imagination that we continue to deepen our understanding of the universe and our place within it. Moreover, visualizations offer a powerful way to illustrate the dynamic processes of cosmic events in a manner that words and equations alone cannot capture. For instance, witnessing the collision of supermassive black holes doesn't just highlight the sheer scale of these cosmic dramas, but also reveals the ripples they send across the fabric of space-time. These stunning visual depictions give us a vivid window into the immense forces at play, showing how they warp the very structure of the universe. This dynamic perspective goes beyond observation, sparking curiosity and prompting deeper engagement with the material. It invites viewers to explore the complexities of space-time, triggering profound questions about the fundamental physics that govern such monumental events. Interactive visualizations add another layer to this experience by empowering individuals to manipulate various parameters and witness firsthand how such changes affect cosmic phenomena. This active participation transforms the experience from passive observation into an engaging learning process. It allows us to experiment with different scenarios, deepening our understanding of the underlying scientific concepts. Through this hands-on approach, we are not merely passive viewers of the cosmos. We become active participants in the grand unfolding story of the universe, making these complex concepts feel more tangible. In a more artistic context, visual interpretations of the universe's beginnings often take on a form that transcends the limitations of scientific representation. Artists use their creative freedom to express ideas that go beyond the rigid constraints of scientific models, transforming abstract, theoretical concepts into sensory experiences. By utilizing color, shape, and texture, artists are able to convey the immense scale and awe-inspiring beauty of creation in ways that words and equations cannot. In contrast, scientific representations focus on theoretical models grounded in empirical data, aiming to explain the origins of the universe through the lens of mathematics, physics, and observations from telescopes and satellites. Take the Big Bang, for example. An artist might depict it as a vibrant explosion of light and energy, with galaxies swirling out of a chaotic, bright center, capturing not only the violence, but also the beauty and dynamism of the event. This artistic portrayal allows viewers to emotionally connect with the creation of the universe, making the unimaginable feel real. On the other hand, scientific diagrams would present a more methodical approach, illustrating equations that describe the expansion of the universe, the formation of elementary particles, and the cooling processes that followed the Big Bang. While these diagrams are invaluable for clarifying our understanding of the universe, they often leave behind the emotional weight that art can evoke. Both approaches, scientific and artistic, seek to answer fundamental questions about our existence, but they do so in radically different ways. While science helps us comprehend the mechanics behind cosmic events, art invites us to reflect on our place in the universe and stirs emotions that numbers and theories alone cannot. Artistic interpretations can spark imagination and inspire curiosity, encouraging viewers to ask deeper questions about the mysteries of existence, questions that go beyond mere facts. Ultimately, the interplay between these two perspectives enriches our understanding of the cosmos. Science grounds us in observable reality, while art allows us to dream, to wonder, and to search for meaning in the vast unknown. As we delve into both the scientific and artistic lenses of cosmic events, we find ourselves on a journey to comprehend the phenomenal world around us, one that bridges the gap between knowledge and imagination. The synthesis of these two fields enables us to appreciate not only the mechanics of the universe, but also the profound mystery it holds. Artificial intelligence, AI, has emerged as a transformative force in the realm of cosmology, with the potential to radically alter our understanding of the universe. By analyzing vast data sets gathered from telescopes, satellites, and other observational tools, AI is able to detect patterns and anomalies that may elude even the most experienced astronomers. These sophisticated algorithms process data with a speed and accuracy that far exceeds human capabilities, enhancing our ability to explore the cosmos in ways previously thought unimaginable. One of AI's most significant contributions to cosmological research lies in the analysis of cosmic microwave background radiation, CMBR, a faint glow that serves as a remnant from the early universe. Tiny fluctuations in this radiation offer crucial insights into the origins and evolution of the cosmos. AI algorithms can dissect these minute variations, identifying patterns that help researchers formulate new theories about the Big Bang, dark matter, and dark energy. Additionally, AI aids in the classification of galaxies, detection of exoplanets, and even in predicting the explosive deaths of stars and supernovae, all by recognizing subtle features that signal different cosmic phenomena. AI is not limited to data analysis. It is also instrumental in designing new experimental approaches and simulations in cosmology. Researchers use AI-driven models to simulate the evolution of the universe under various conditions, allowing them to test different hypotheses and gain new insights into the laws of physics. This computational prowess enables astronomers to assess the success of different cosmological models, helping them refine our understanding of the universe's expansion rate and the fundamental forces that govern it. As AI continues to evolve, so too does its potential to revolutionize our understanding of the universe. The ability to automate large-scale analyses and uncover new patterns presents an exciting opportunity to push the boundaries of our knowledge. AI is not just a tool for answering questions, it is a means of asking new ones, facilitating innovative theoretical frameworks that could reshape our understanding of cosmology. Through this intersection of technology and scientific inquiry, we are moving closer to unraveling the secrets of the universe at one algorithmic breakthrough at a time. Theories about the origins of the universe are not just abstract constructs. They form the very foundation of how we understand the cosmos and our place within it. Central to these theories is the Big Bang model, which suggests that the universe began around 8 billion years ago from an incredibly hot and dense state. This event triggered the creation of space-time itself, along with matter and energy, setting the stage for the formation of galaxies, stars, and ultimately the planets on which life would emerge. As we explore the universe's evolution, we begin to see how deeply intertwined our lives are with the cosmos. Every atom in our bodies was forged in the hearts of stars. This incredible truth connects us to the universe in a profound way, reminding us that we are not separate from the cosmos, but an integral part of an immense interwoven tapestry of existence. Elements such as carbon, nitrogen, and oxygen, critical for life, were formed in stellar furnaces, and their very presence within us shapes how we view our own existence. Each breath we take is a reminder of our shared cosmic ancestry. Theories about the origins of the universe also raise profound philosophical and existential questions. If the universe began with a single defining event, what does this mean for our understanding of time, beginnings, and ends? Such considerations challenge us to reflect on concepts like causality, the vast stretches of time, and the potential future evolution of everything from galaxies to human cultures. The exploration of the universe's origins pushes us to look beyond our immediate experiences and think more deeply about our place in the grand narrative of existence. It prompts us to consider what it means to be human in a universe that began long before us and will continue long after. This exploration doesn't just inspire scientific inquiry, it also catalyzes curiosity in a broader sense, influencing fields like philosophy, art, and even literature. By contemplating the origins of the universe, we gain profound insights into the nature of reality and foster a deeper sense of interconnectedness with the cosmos. This ongoing search for understanding enriches our appreciation for the complexity and beauty of existence itself, as each moment spent pondering the mysteries of the universe deepens our connection to the very fabric of reality. Discussions about the origins of everything extend far beyond academic speculation. They touch deeply on questions of personal identity and meaning. When individuals contemplate the beginnings of the universe, of life, and of consciousness itself, they are often compelled to reflect on their own existence. Understanding where we come from can significantly shape how we view ourselves and our roles in the world. Concepts like the Big Bang or evolutionary biology challenge long-held beliefs about the human condition, prompting a reassessment of our purpose and our place within this grand cosmic story. For some, these debates lead to a strengthened belief in a particular worldview, while for others, they ignite a new quest for meaning and understanding in the vast, mysterious universe. The implications of scientific discoveries extend far beyond the realm of empirical knowledge. They ripple through the very fabric of cultural, spiritual, and philosophical identities. People, shaped by their diverse cultural backgrounds, approach the origins of the universe from varying perspectives, whether scientific, religious, or philosophical. These varied interpretations enrich the dialogue, offering a profound tapestry of understanding. When individuals encounter contrasting views, they are often compelled to examine their own beliefs and assumptions, which can catalyze personal growth and self-discovery. In essence, the search for the origins of the universe becomes a mirror reflecting our own identities, both individual and collective. In exploring where everything began, we are simultaneously coming to terms with who we are today and how we relate to one another in the vast expanse of existence. The conversation surrounding the cosmos is not just about distant galaxies or cosmic dust. It is, in fact, deeply intertwined with our personal journeys and collective narratives. This intersection between cosmic knowledge and personal reflection shapes our understanding of identity, for urging a sense of connection, both to the universe itself and to the people around us. In this light, cosmology becomes a bridge that links our own sense of self with a greater, shared story of existence. As humans delve into the depths of cosmology, public engagement with this field has far-reaching consequences for how we respond to existential challenges. The more we learn about the enormity of the universe, the intricate laws that govern its motion, and the mysterious origins of existence, the more our perspectives on life's challenges begin to shift. When confronted with daunting questions like the future of humanity or the accelerating pace of environmental degradation, the insights from cosmology provide a broader, more encompassing context. Earth, as we now know, is a mere speck in a vast, swirling cosmos. This realization can spark a sense of humility, a humbling reminder of our insignificance in the grand scheme of things. Yet, paradoxically, this sense of vastness can also unite us. We share this tiny, fragile planet floating in the cosmic ocean, and this shared home can inspire a sense of duty toward each other and the planet. Rather than succumbing to feelings of isolation and despair, this cosmological perspective can foster collective action and responsibility. Recognizing our place in the universe often ignites a renewed sense of purpose, a shared drive to address issues like climate change, resource depletion, and social inequities. In a sense, our understanding of the universe's vastness can galvanize us to collaborate more effectively, drawing on the collective will to build a sustainable and thriving future for all. What once seemed like overwhelming challenges can be reframed as opportunities for change, driven by a deep understanding of our interconnectedness and our potential for positive transformation. Moreover, engaging with cosmology often sparks a profound sense of curiosity about the unknown, shifting the focus from despair to exploration. Learning about cosmic phenomena such as the enigmatic black holes or the life cycles of stars can instill a sense of awe that reminds us of the infinite mysteries still waiting to be uncovered. This sense of wonder, so deeply ingrained in the study of the cosmos, can transform existential anxiety into excitement about the limitless possibilities for discovery. Instead of being paralyzed by uncertainty, individuals can learn to embrace it, seeing the unknown as an essential part of the human experience, a source of inspiration, creativity, and progress. This shift in perspective, brought about by the exploration of the cosmos, not only addresses existential crises on a personal level, but also nurtures broader societal dialogues. Public lectures, community discussions, and portrayals of cosmological phenomena in popular media catalyze critical conversations about our place in the universe. These discussions often serve as a springboard for deeper philosophical reflections on the nature of existence, the purpose of life, and the future of humanity. By actively engaging with these topics, societies are not merely enhancing individual lives, they are cultivating a shared narrative that emphasizes resilience, unity, and hope, in the face of adversity. Understanding the cosmic history of our universe reveals an extraordinary journey, one that stretches across billions of years. From the cataclysmic moment of the Big Bang, our universe began to expand, setting into motion a complex sequence of events that led to the formation of stars, galaxies, and ultimately, planets. This grand narrative underscores the interconnectedness of all matter, inviting us to consider that the very elements that make up our bodies were once forged in the hearts of stars. We as human beings are literally made of stardust, a profound reminder of the intimate connection between ourselves and the cosmos. This awareness of our celestial origins carries with it a profound sense of belonging, as if we are part of a larger, ongoing story that began long before we were born and will continue long after we are gone. Recognizing that we are born from the same stellar materials that form galaxies and nebulae can stir a deep sense of unity among people. Our differences, when viewed through the lens of the cosmic journey, seem trivial when contrasted with the vastness of time and space that we share. Understanding our cosmic heritage encourages individuals to adopt a sense of stewardship toward Earth, recognizing that we are caretakers of this fragile planet, entrusted with its preservation for future generations. This shared understanding of our origins fosters a collective purpose, one that transcends national, cultural, and religious boundaries. As we explore the origins of the universe and the deep history of existence, we gain a broader, more inclusive perspective, one that encourages us to embrace our shared humanity. When we recognize that we are part of a cosmic continuum, the distinctions that often divide us seem less significant. Instead, we are reminded of our common journey through time and space, a journey that unites us all in the pursuit of knowledge, understanding, and the preservation of life on this small, precious planet. The exploration of the universe is ultimately the exploration of ourselves. As we venture deeper into the mysteries of existence, we not only uncover the secrets of the cosmos, but also the truths about our own nature and our place within this grand narrative. And in doing so, we find that the boundaries between the cosmos and ourselves are not as distinct as we once believed. The universe is not a distant, detached entity, but a living, breathing reality to which we belong, as much a part of it as the stars that light the night sky. Understanding the history of the cosmos encourages us to think far beyond the confines of our immediate surroundings. It compels us to question not just the present, but also the future of humanity. What legacy will we leave for those who follow us? How will future generations view our actions, our decisions, and the way we navigated our existence on Earth? This perspective, rooted in our connection to the vast universe, has the potential to inspire not only individual reflection, but also collective action. By understanding the deep narrative of cosmic history, we may cultivate a renewed sense of responsibility. Responsibility not only to our fragile planet, but also to the entire cosmos. This awareness has the power to foster cooperation, creativity, and innovation. It underscores the need for humanity to work together across borders to tackle global challenges that threaten not just our well-being, but the future of all life on Earth. By engaging deeply with our cosmic past, we can open the door to a future driven by wonder and curiosity. The history of the universe, with all its breathtaking scale and complexity, reminds us of the endless possibilities that lie ahead. It calls us to look at the world and our place in it with awe, urging us to embrace our role not just as inhabitants of Earth, but as explorers and guardians of this delicate blue planet, floating like a rare jewel amid a vast sea of stars. It is only by reflecting on where we come from and where we are headed that we begin to understand the true power of collective spirit. This spirit unites us across time, geography, and experience, pushing humanity forward into the uncharted waters of the future. The origins of the universe hold a profound influence on the human experience. Understanding that our universe began with a single, extraordinary event known as the Big Bang, approximately 14 billion years ago, invites us to see our existence as part of something far greater than ourselves. This realization is both humbling and empowering. The knowledge that the atoms that make up our bodies were once part of ancient stars, that we are, in essence, stardust, creates a powerful sense of interconnectedness with all things. It positions us within a vast cosmic tapestry, one that spans unimaginable distances and timescales. This awareness has the potential to spark awe and curiosity, fueling the desire to seek answers to the fundamental questions that have intrigued humanity for millennia. What is the purpose of life? What is our place in the cosmos? And perhaps most importantly, are we alone in the universe? This profound understanding pushes the boundaries of our imagination, prompting us to marvel at the creation of galaxies, the formation of stars, and the delicate interplay of celestial bodies. As we look up at the night sky, we are reminded that everything we know, our planet, our species, our very existence, has been shaped by a complex web of cosmic events. Our planet Earth was born from this same cosmic furnace, where elements were forged in the hearts of stars. These elements eventually coalesce to form the life-sustaining environment we inhabit today. Yet delving into the complexities of the universe's origins can also evoke a sense of insignificance. The enormity of space and time, the vast number of stars and galaxies stretching beyond our comprehension, can make our human concerns seem small and fleeting. In the face of such immensity, the struggles, joys, and sorrows of individual lives may appear inconsequential. Some may feel a deep existential unease, a realization that our lives, brief as they are in the grand scale of cosmic time, seem almost insignificant. This recognition of our smallness can lead to an existential crisis, where we wrestle with the meaning of our experiences and the purpose of our existence. However, rather than diminishing our sense of purpose, an understanding of the universe's origins can deepen our appreciation for life itself. It compels us to recognize the fragility of existence, reminding us that we are part of a brief and precious moment in a universe that is constantly evolving. This understanding pushes us to form meaningful connections with one another, to cherish the time we have, and to strive for a world where life flourishes, both on Earth and potentially elsewhere in the cosmos. In this way, the pursuit of knowledge about our origins does not lead to despair, but rather to a greater sense of reverence for the journey we are on, both as individuals and as a species. Ultimately, exploring the history of the cosmos is like solving a vast and intricate puzzle. Each piece offers new insights into the conditions that gave birth to the universe as we know it. By studying the formation of galaxies, stars, and planets like Earth, we learn about the fundamental processes that govern the cosmos. For example, ancient light from the cosmic microwave background radiation allows us to peer into the early moments of the universe, providing crucial information about how everything that followed came into being. This knowledge, in turn, shapes our understanding of the universe and our place within it. The more we learn about the origins of the universe, the more it influences the trajectory of our future explorations. For instance, the understanding of the conditions that make life possible on Earth informs the search for life elsewhere in the universe. As we study planets and moons beyond our solar system, scientists look for environments that might support life as we know it. Missions to locations like Europa and Enceladus, moons of Jupiter and Saturn, are driven by the hope that they may harbor the conditions necessary for life. The presence of water, the right chemical elements, and the right temperature could make these moons potential havens for life forms. By studying the universe's past, we are also better equipped to predict where and how to search for life beyond Earth. Knowledge about how life arose on our planet guides us in identifying exoplanets and moons with similar environments. In this way, the understanding of the cosmos not only deepens our sense of wonder, but also propels humanity toward new frontiers in the search for alien life. And with each discovery, we move one step closer to answering the profound question, are we alone in the universe? As we continue our journey through the stars, it is the story of the universe itself that drives us forward. A story that stretches back to the birth of time and extends into an unknowable future, inviting us to explore, to question, and to imagine what lies beyond the horizon. Our understanding of the cosmos is a deep well of knowledge that continually shapes our perceptions of the universe and our place within it. As we explore the vastness of space, we not only seek answers to age-old questions, but also unearth profound insights that impact our future. Events like supernovae and gamma-ray bursts are not just cosmic spectacles, but vital lessons from our celestial heritage. These phenomena, which have shaped Earth's environment throughout its history, offer us critical knowledge that could inform strategies for our survival in an unpredictable future. By studying the patterns of past cosmic occurrences, we can build more robust frameworks for dealing with similar events when they inevitably arise. This historical perspective is invaluable. It does more than enhance our scientific understanding. It also propels the development of new technologies that enable us to continue exploring the cosmos. Advanced space telescopes, autonomous robotic explorers, and other cutting-edge tools allow us to peer deeper into the universe's secrets than ever before. Every breakthrough in technology and discovery brings us one step closer to unveiling the mysteries of the universe's vast timeline. Each revelation is a stepping stone, building on the last, propelling us to new frontiers of understanding. This unbroken cycle of inquiry not only advances science, but also leads to innovations that push the boundaries of human exploration, helping us venture further into the unknown and redefine our relationship with the cosmos. Public skepticism has always played a pivotal role in shaping scientific progress. Throughout history, the questioning of theories and concepts about the origins of the universe has pushed scientists to refine their hypotheses, making them more robust and compelling. It was public skepticism, for instance, that drove the acceptance of ideas like the Big Bang Theory and cosmic inflation. What were once speculative concepts are now foundational pillars of cosmological thought, only after being subjected to rigorous testing and validation through astronomical observation. Moreover, skepticism serves as a catalyst for education. When the public questions scientific claims, it opens up an avenue for dialogue where scientists and educators can clarify misconceptions and engage in deeper discussions about complex topics like the nature of the universe. This exchange of ideas fosters a richer understanding of science, helping the public appreciate the scientific method and the vital role of evidence in forming conclusions about the universe's origins. Importantly, skepticism does not only question the validity of scientific ideas, it can also inspire curiosity, motivating individuals to explore the cosmos more deeply and passionately. In this way, skepticism transforms from a potential obstacle to a powerful driving force in the pursuit of knowledge. The role of public skepticism extends beyond mere criticism. It shapes the way scientific ideas are communicated and accepted by society. By challenging accepted theories, skepticism ensures that cosmological concepts are not just accepted, but understood. This process fosters a culture of inquiry, where the pursuit of truth is not driven by dogma, but by the continuous accumulation of evidence and the willingness to revise our understanding as new information emerges. Looking back over 13 billion years to the dawn of our universe is a humbling experience. The Big Bang, the birth of stars, the formation of galaxies, and the emergence of life on Earth all tell a grand narrative of cosmic evolution. As we unravel this story, we come to realize that our planet is not just a random rock in space, but a unique and precious product of this long history. This awareness of Earth's place in the vast cosmos leads to a profound sense of responsibility. Our planet, a tiny oasis in the vast emptiness of space, is not just home to humanity, but to all forms of life. Recognizing the extraordinary conditions required for Earth's formation, we are reminded of how fragile and interconnected the planet's ecosystems are. This cosmic context urges us to rethink our relationship with the environment. Instead of seeing ourselves as separate from nature, we begin to understand our role as stewards of this fragile planet. The recognition that Earth's resources are finite compels us to take action to preserve its ecosystems. In the same way that stars go through cycles of birth, brilliance, and eventual fading, we too must evolve our consumption patterns. Sustainable living, renewable energy, and conservation efforts are not merely a choice. They are an imperative driven by our understanding of the universe and the finite nature of the resources that sustain us. As we face modern environmental crises, climate change, biodiversity loss, and resource depletion, the cosmic perspective offers valuable lessons. The universe, with its billions of years of history, offers a long-term view that helps us understand the consequences of our actions. Just as the stars have burned brightly and faded over eons, our civilization must also learn to adapt, ensuring that we can live in harmony with the Earth's natural systems. The resilience of life across cosmic time serves as a hopeful reminder that while our environment is fragile, life itself is remarkably adaptable. This awareness encourages us to innovate, rethink our lifestyles, and move toward a more sustainable future. The realization of our cosmic origins deepens our connection to Earth and encourages a greater commitment to safeguarding the delicate balance that sustains life. But this understanding does not belong solely to scientists or philosophers. It resonates through the creative arts as well. Throughout history, artists have used the cosmos as a lens to explore the mysteries of existence. Whether in painting, sculpture, or music, the grandeur of the night sky and the vastness of the universe have inspired creative expressions that stir our sense of wonder and awe. Renaissance artists, for example, were influenced by the groundbreaking scientific discoveries of their time. The study of light and shadow in both art and astronomy mirrored the new understandings of the universe. Artists like Vincent van Gogh, with his iconic Starry Night, infused their work with emotional depth, capturing the swirling energy of the cosmos and reflecting the dynamic nature of the universe. His painting invites viewers to feel the movement of the stars and ponder the vastness of existence. In more contemporary times, artists like Olafur Eliasson use light, space, and innovative installations to immerse viewers in cosmic experiences, inviting them to engage directly with the mysteries of the universe. These installations transform the viewer from a passive observer into an active participant in the dialogue between art and science. Through art, we are invited to experience the cosmos in new and profound ways. Whether through the contemplation of a painting, the immersion in an installation, or the study of scientific theories, the cosmos continues to inspire humanity. The intersection of art and science not only enhances our understanding of the universe, but also connects us more deeply to the mysteries of existence and our place within the cosmic order. Through these lenses, science, art, and inquiry, we are reminded of the infinite possibilities that lie ahead as we can continue our exploration of the cosmos. The intersection of literature, poetry, and cosmic themes has long been a wellspring of inspiration for writers who seek to probe the deeper mysteries of existence. For centuries, authors have used the vast expanse of the universe as a mirror to reflect on life's most profound questions, often grappling with the meaning of our existence in a seemingly endless cosmos. In works by writers like Carl Sagan and Jorge Luis Borges, we encounter philosophical explorations that echo humanity's innate yearning to comprehend not just the universe's structure, but our role within it. These reflections are not confined to the boundaries of fiction or scientific inquiry. Instead, they offer a window into the deep existential wonder that permeates human thought. Art, in this context, serves as a bridge between the worlds of science and the human experience. By weaving together the celestial with the human, literature invites us to reflect on our place in the cosmos. These works stir within us a powerful desire to seek understanding, offering insights that resonate with our eternal search for meaning beneath the stars. The allure of uncovering the mysteries that lie before the Big Bang, what existed, if anything, before the birth of our universe, has fueled both scientific discovery and philosophical contemplation. This question, fundamental to our quest for knowledge, is a beacon that draws researchers into the unknown. At the heart of these explorations lies the profound curiosity about the origins of everything we know. The Big Bang Theory, which describes the birth of the universe, is a remarkable achievement in our understanding of the cosmos. Yet, despite its far-reaching implications, it leaves one tantalizing mystery. What preceded this monumental event? This question, elusive and compelling, propels scientists to venture beyond the known and into the speculative realms of theoretical physics and philosophy. Here, the pursuit of knowledge meets an insatiable desire to uncover the very fabric of reality. For scientists, the quest is driven by the hope of piecing together a coherent narrative of creation. By studying cosmic microwave background radiation, observing the behavior of galaxies, and analyzing the principles of quantum mechanics, they seek to reconstruct the origins of the universe. One possibility that has emerged from these efforts is the theory of the multiverse, the notion that our universe might be only one of countless others, each with its own set of laws and conditions. This concept challenges our understanding of space and time, raising new questions about the very nature of reality itself. The idea that time itself could have behaved differently before the Big Bang adds another layer of complexity to the scientific puzzle, encouraging further investigation into the earliest moments of existence. The rapid expansion of the universe, immediately following the Big Bang, as outlined in inflationary theory, is another area of intense scientific inquiry. This theory suggests that the universe expanded at an incomprehensibly fast rate, and understanding the conditions that could have led to such a transformation remains one of the great mysteries of modern cosmology. Yet, while science continues to push the boundaries of what we know, there are philosophical questions that may forever elude empirical observation. Philosophers, too, grapple with the implications of existence, but from a different perspective. Whereas scientists focus on the how of creation, philosophers contemplate the why. What does it mean for something to arise from nothing? This inquiry transcends the confines of empirical observation, inviting us to ponder abstract concepts like infinity, causality, and the very nature of time. Existential questions about the origins of the universe often lead to discussions about metaphysics, the branch of philosophy that addresses the fundamental nature of reality. These discussions invite us to consider the limits of human understanding, helping to position our search for knowledge within a broader context of human experience. In this way, the intersection of scientific and philosophical exploration creates a fertile ground for dialogue, enriching our collective understanding of existence and reality. Together, these quests challenge us to expand our vision, encouraging us to rethink our assumptions and explore new frameworks for understanding our place in the universe. As we venture into the unknown, we are confronted with fundamental questions about our origins that may forever shape our views on existence itself. In the process, the very act of searching for answers becomes an integral part of the human narrative, a shared journey toward understanding that transcends generations and cultures. The quest for knowledge about the origins of the universe is not a new phenomenon. Throughout history, humanity has consistently sought to understand its place in the cosmos, and this pursuit has evolved in fascinating ways. In ancient civilizations, mythologies served as the primary means of explaining the cosmos. The Babylonians and Greeks, for example, looked to the heavens, weaving intricate narratives about the movements of celestial bodies and attributing them to the actions of gods and divine forces. These early stories laid the foundation for more systematic observations and theories that would emerge centuries later. As intellectual thought progressed, so too did our approach to cosmology. During the Renaissance, figures like Nicolaus Copernicus revolutionized our understanding of the universe by proposing the heliocentric model, placing the sun at the center of the solar system instead of the Earth. This groundbreaking idea challenged long-held beliefs and sparked significant debate, paving the way for future advancements in our understanding of the cosmos. Later, astronomers like Johannes Kepler, with his laws of planetary motion, and Galileo Galilei, with his pioneering work with the telescope, further emphasized the importance of empirical evidence in the study of the universe. The 19th and 20th centuries marked a new era of scientific exploration. During this time, the Big Bang theory was formulated, and the notion that the universe was expanding was first proposed by Edwin Hubble. These revelations painted a picture of a dynamic and ever-evolving cosmos, one that was far more complex than anyone had previously imagined. This period also saw the development of more advanced telescopes and sophisticated technologies that allowed astronomers to peer deeper into the cosmos, revealing a universe teeming with galaxies, stars, and other cosmic phenomena. These discoveries continue to astonish us today, driving further exploration and inquiry. As our tools for observing the universe have grown more advanced, so too have our techniques for understanding its origins. Today, scientists employ methods like gravitational wave detection and cosmic microwave background radiation analysis to investigate the universe's infancy. Each new discovery brings us closer to unraveling the fundamental forces and materials that shape the cosmos, deepening our understanding of the universe's complex and dynamic nature. However, the quest to understand the universe's origins also raises important ethical questions. As we probe deeper into the mysteries of existence, we must also consider the potential implications of our discoveries. One significant concern is the impact that these revelations might have on individual beliefs and societal norms. For instance, the knowledge of the universe's origins could challenge traditional religious interpretations, leading to conflicts that require careful and thoughtful navigation. These ethical dilemmas highlight the responsibility that comes with the pursuit of knowledge, reminding us that scientific and philosophical inquiries are not conducted in a vacuum, but are deeply intertwined with the fabric of human society and culture. Thus, as we continue to unravel the secrets of the cosmos, we must do so with an awareness of the broader implications of our discoveries, both for our understanding of reality and for our collective place within it. The exploration of consciousness, especially within the realm of neuroscience, is not without its ethical dilemmas. As we push forward in our ability to probe the depths of the human brain, we are confronted with questions that challenge our most fundamental concepts of privacy, consent, and the integrity of human cognition. Technologies are advancing at a remarkable rate, allowing us to interact with the brain in ways once thought impossible. However, with this newfound power comes an urgent need to grapple with the consequences of manipulating thought, memory, and identity. At what point does intervention in the brain cross the line from enhancement to coercion? This is a central concern as we consider how far we should go in altering the very core of what makes us human. Moreover, the pursuit of understanding existence itself requires vast resources, funding, cutting-edge technology, and the tireless efforts of researchers. This raises a host of questions about priorities and responsibilities. How do we balance investments in fundamental research with the very real and pressing issues we face, such as poverty, climate change, and public health? It's a question that extends beyond the scientific community to society at large, forcing us to confront our ethical obligation to allocate resources in a way that maximizes benefit for all of humanity. As we continue our exploration of existence, we must consider whether we are pursuing knowledge in a manner that is responsible and equitable, ensuring that our discoveries do not deepen societal divisions, but instead contribute to human flourishing. A critical aspect of this responsibility lies with science communicators and researchers, who must present their findings with integrity and transparency. In an age where misinformation is rampant, the accurate portrayal of scientific knowledge is vital. Misrepresentations or misinterpretations of scientific ideas can quickly ripple through society, leading to widespread confusion and misconceptions. As we advance in our understanding of existence, ethical considerations will remain paramount. We are constantly being urged to reflect on the potential consequences our discoveries may have, not just on the scientific community, but on the world as a whole. It is essential that the knowledge we gain contributes to a greater collective good, rather than division or misunderstanding. This is where scientific literacy becomes so crucial. In a world where complex questions about the universe abound, from the origins of the cosmos to the possibility of extraterrestrial life, it is vital for individuals to have a solid understanding of scientific principles. The more people understand the methods that guide scientific inquiry, the better equipped they are to navigate the complexities of topics like black holes, the Big Bang, or the mysteries of dark matter. This knowledge demystifies these subjects, allowing individuals to engage in meaningful discussions and make informed decisions about the implications of scientific advancements. Moreover, scientific literacy fosters critical thinking skills, an invaluable tool in an era saturated with misinformation. Individuals trained to evaluate evidence, question sources, and understand the scientific process are less likely to fall victim to sensational claims or pseudoscience. The role of scientific literacy extends far beyond the individual level. In societies where scientific understanding is prioritized, public support for research tends to flourish. This support translates into increased funding for scientific programs, from space exploration missions to advancements in astrophysics. When communities actively engage with scientific issues, they are more likely to advocate for policies that promote education in the sciences and provide resources for research institutions. As more individuals participate in the discourse surrounding cosmology and other scientific fields, the public narrative surrounding these topics becomes richer and more diverse. People from various cultural and intellectual backgrounds bring unique perspectives, enhancing our collective understanding of the universe. A society that values scientific literacy is one that is more likely to foster collaboration, innovation, and progress. At a more profound level, the pursuit of knowledge about the cosmos and existence is also a cultural endeavor. The questions of who we are, why we exist, and what lies beyond our perception of the universe have always been central to human inquiry. Scientific literacy plays a key role in shaping how we, as a society, approach these existential questions. It ensures that we do not approach cosmological mysteries with superstition or conjecture, but with curiosity, reason, and respect for the processes of scientific discovery. In this way, a scientifically literate society has the power to inspire future generations to continue exploring, questioning, and seeking out answers to the most profound questions about our place in the cosmos. The intersection of untestable hypotheses and rigorous scientific inquiry presents a fascinating challenge to theorists in fields like cosmology. Traditionally, a hypothesis is only considered valuable if it can be tested through experimentation or observation. However, many of the most profound questions in cosmology, such as the nature of dark matter and dark energy, are currently beyond the reach of direct observation or experimentation. These phenomena continue to puzzle scientists, leading to hypotheses that are speculative, and in some cases difficult or even impossible to test with today's technology. To navigate this challenge, theorists employ a multifaceted approach. They begin by grounding their hypotheses in established scientific principles, drawing on a rich foundation of empirical data. The goal is not merely to come up with imaginative ideas, but to ensure that these ideas are consistent with what is already known. In the face of the unknown, theorists create models that predict how certain phenomena might behave under various conditions, even if those conditions cannot yet be replicated in a laboratory or observed directly through current instruments. These models serve as a framework for future exploration, guiding new experiments and observations as technology continues to evolve. This method allows for progress in our understanding of the cosmos, even when some questions remain tantalizingly out of reach. In this delicate balance between known science and speculative theory, the pursuit of knowledge becomes a journey of both discovery and imagination, one that continuously pushes the boundaries of what is possible and challenges us to rethink the very nature of the universe. The rapid evolution of technology continually transforms what was once deemed untestable into the realm of possibility. As instruments and tools for measurement advance, our capacity to observe and quantify phenomena that were once purely theoretical has expanded dramatically. This shift is perhaps best exemplified by the detection of gravitational waves, a phenomenon that was, not long ago, an unprovable hypothesis. Yet, with the advent of ultrasensitive detectors, we now have the ability to measure these waves, which not only confirm Einstein's predictions, but also deepen our understanding of the universe in ways we never imagined. In instances where direct experimentation remains out of reach, theorists step in to explore the broader implications and consequences of their ideas within a larger scientific framework. These thinkers rigorously evaluate their hypotheses, carefully considering the possible outcomes and designing secondary hypotheses that can be empirically tested. This approach preserves the integrity of the scientific method, but it also fosters a lively exchange of ideas within the scientific community. Through this ongoing dialogue, the boundaries of human knowledge are continually pushed, opening new doors to realms of discovery previously thought to be beyond our grasp. The marriage of rigorous scientific examination and creative thinking serves as the primary engine of scientific advancement. It propels humanity forward, bringing us ever closer to unraveling the mysteries of the cosmos. This relentless pursuit, however, does not happen in isolation. Collaborative efforts play a pivotal role in enhancing our collective understanding of existential questions, queries that often cross the boundaries of individual disciplines. When scientists, philosophers, theologians, biologists, and physicists come together, they create a multifaceted tapestry of insights that contribute to a more profound understanding of our place in the universe. Interdisciplinary research is especially crucial in tackling these existential puzzles. By blending the hard sciences with the humanities, scholars are able to approach questions such as the nature of consciousness, the origins of the universe, and the meaning of life from multiple angles. Universities and research institutions increasingly promote these collaborations, recognizing that insights from diverse fields can enrich our understanding of some of the most pressing and perplexing questions. Conferences, workshops, and symposiums devoted to exploring existential themes also act as hotbeds for groundbreaking ideas, where free-flowing discourse and the exchange of perspectives can ignite new ways of thinking. This synergy between various academic fields is essential, especially when tackling the complexities of existential inquiries. These questions do not reside neatly within one discipline. They lie at the crossroads of knowledge, often requiring input from many perspectives to achieve a more holistic understanding. In many ways, this convergence of ideas helps bridge the gaps between what we know and what we have yet to explore. It is a continual process of exploration that challenges the very foundations of our understanding. Public engagement has a similarly vital role to play in these discussions. As scientific and philosophical debates shift into the public sphere, they become more accessible to a wider audience. Public forums, lectures, and educational programs create platforms where people from all walks of life can contribute to and engage with these profound topics. This democratization of knowledge ensures that a greater diversity of perspectives enriches the conversation, leading to new questions and insights that may otherwise have been overlooked. By involving the general public, we not only expand the scope of the dialogue, but also bring the collective wisdom of humanity into the quest for answers. In addition, the rapid advancement of technology has revolutionized the way researchers collaborate. Digital communication platforms now allow scientists from every corner of the globe to share their findings, engage in meaningful dialogue, and work together on joint projects without the limitations of geography. This interconnectedness accelerates the pace of discovery and broadens the pool of ideas and viewpoints, adding layers of depth to our collective understanding of the profound questions that shape our existence. Historical perspectives are another crucial component in this ongoing inquiry into the cosmos. The rich tapestry of ideas, theories, and paradigms developed over centuries provides vital context for modern scientific and philosophical debates. Ancient civilizations, for example, sought to explain the cosmos through mythological narratives, often attributing its origins to gods and divine forces. This reflects a deeply rooted human desire to find meaning in the universe, a pursuit that continues to this day. As time progressed, figures such as Claudius Ptolemy and Nicholas Copernicus reshaped the narrative, offering models that placed planets within a structured, heliocentric universe. These developments marked a dramatic shift in how humanity understood its place in the cosmos. However, these evolving views remind us that our current understanding is not static. It has been shaped by centuries of exploration and discovery. More recently, groundbreaking figures like Isaac Newton and Albert Einstein fundamentally altered our understanding of the laws of motion and gravity, laying the groundwork for modern cosmology. These advances not only expanded our knowledge of space-time, but also provided the tools needed to explore the universe on a far grander scale. Understanding these historical frameworks is essential for anyone engaged in contemporary scientific discourse. They allow us to appreciate the complexities and challenges faced by earlier thinkers and provide invaluable context for today's research. Moreover, they remind us that the knowledge we possess today is the result of centuries of collective effort, built upon the work of those who came before us. Every new discovery is part of an ongoing process, with each step forward standing on the shoulders of giants. When considering the origins of the universe, events such as the Big Bang, these historical perspectives provide essential guidance. They help blend philosophical reflection with empirical evidence that's better, encouraging nuanced dialogues that account for both the scientific and cultural dimensions of our quest for understanding. These perspectives also remind us that every question we ask today has deep roots in the intellectual history of humanity. Our search for answers is not simply a contemporary endeavor. It is an age-old pursuit that has evolved over time shaped by countless minds and cultures across the centuries. The quest to understand the universe is as grand as it is complex, spanning disciplines such as physics, astronomy, cosmology, philosophy, and even psychology. As researchers from these varied fields work to create a cohesive understanding of the cosmos, they face a range of challenges. One significant hurdle is the inherent differences in methodology between these disciplines. Physics, for example, relies on mathematical models and experimental validation, while philosophy often embraces abstract reasoning and metaphysical speculation. Bridging these two approaches requires a willingness to engage in dialogue and find common ground, something that is often elusive but essential if we are to make meaningful progress in our understanding of the universe. Thus, the journey to uncover the mysteries of existence is not just about accumulating data or formulating theories. It is a deeply collaborative, interdisciplinary effort that requires constant dialogue, creative thinking, and the willingness to push the boundaries of what we know. Whether through the rigorous testing of hypotheses or the synthesis of diverse perspectives, the pursuit of knowledge about the cosmos is a dynamic and ongoing process. As we continue on this path, we are bound to encounter new questions, challenges, and revelations, each of which will bring us closer to the ultimate understanding of our place in the universe. The vast expanse of human knowledge presents a formidable challenge, not only in its sheer scale, but also in how it is organized and understood. Every academic discipline offers its own distinct perspective, adding a unique layer of insight to our collective comprehension of the universe. However, weaving these diverse perspectives into a coherent framework can seem like an impossible task, like trying to assemble a jigsaw puzzle with pieces that come from different boxes, each bearing its own set of rules and logic. This struggle is especially evident in the realms of science and philosophy, where the complexity of each subject demands attention to minute details, while also striving for a broader, more unified understanding of the world. Take, for example, the fields of physics and cosmology. Physicists often focus on the infinitesimally small, studying the behavior of subatomic particles and the fundamental forces that govern them at the quantum level. In contrast, cosmologists zoom out, exploring the grandeur of the universe itself, the vast networks of galaxies, the birth and death of stars, and the cosmic background radiation that permeates the universe. While both fields tackle questions of immense importance, their scales and approaches are worlds apart. To unify these disparate perspectives requires more than just collaboration. It demands creative thinking and new methodologies that can bridge the gap between the tiny particles of quantum mechanics and the sweeping phenomena of cosmic evolution. As if the complexity of integrating these fields wasn't enough, there is also the ever-evolving nature of scientific inquiry. In the world of research, discoveries are constantly being made that challenge long-standing assumptions. For instance, the discovery of dark matter and dark energy, mysterious substances that make up the vast majority of the universe, forced cosmologists to rethink the traditional models of the cosmos. What was once considered a well-established framework for understanding the universe's origins now requires constant refinement and adjustment in light of new data. This fluidity, though exciting, creates an intellectual landscape that is often resistant to change, particularly in academic and philosophical circles where established theories are deeply entrenched. The constant flux of new information and the ongoing refinement of theories also underscores a central issue in science: the balance between openness to new ideas and the stability of established knowledge. The scientific community's ability to embrace paradigm shifts while still honoring the work that came before is essential for making meaningful progress. Yet, this balance is often difficult to achieve. The academic world, for instance, can be slow to adopt new ideas that challenge the foundational principles of a discipline. In the face of such resistance, scientific theories must remain flexible, open to reinterpretation, and subject to ongoing scrutiny. One significant barrier to progress lies in the communication of scientific ideas. As research becomes increasingly specialized, jargon and technical language can alienate those outside a specific field of study. This creates a communication gap that complicates interdisciplinary collaboration and makes it harder for scientific ideas to resonate with a broader audience. Scholars and scientists, therefore, have a responsibility to communicate their findings clearly and accessibly. This effort is not just about making research digestible for the general public, it's about fostering a cultural appreciation for science that can transcend academic boundaries and inspire curiosity in people from all walks of life. This necessity for clear communication becomes all the more critical when we consider how future generations will view the theories we hold dear today. Our current understanding of the universe, such as the Big Bang Theory and the concept of cosmic inflation, may one day be seen as quaint or oversimplified in light of new discoveries and advances in technology. What we consider cutting-edge science today may, in the future, be regarded as a stepping stone toward more sophisticated, accurate theories. For example, our current models of dark matter and dark energy, while groundbreaking, may only represent a preliminary phase in the journey to understanding the true nature of the cosmos. As technology advances and observational tools become more precise, future scientists will likely discover phenomena that force a complete rethinking of current models. These revelations could lead to entirely new ways of understanding the universe, altering our perceptions of time, space, and existence itself. Our current theories, grounded in observation and mathematical models, could be revised or even abandoned in favor of fresh, more comprehensive frameworks that better align with new evidence. This process of ongoing discovery will not only expand our knowledge of the universe, but may also provide new insights into the fundamental nature of reality. The implications of these shifts extend beyond the realm of science. As our understanding of cosmic origins evolves, so too will the philosophical questions surrounding time, space, and existence. The future may bring a more integrated approach to these issues, with science and philosophy merging in ways that are difficult to imagine today. This philosophical evolution could lead to a more holistic narrative about our place in the universe, one that takes into account not only scientific principles but also cultural beliefs, existential questions, and the broader human experience. The interconnectedness of scientific discovery means that each generation builds upon the foundations laid by those that came before. New evidence and breakthroughs in one field can ripple across the broader landscape of human knowledge, leading to transformative shifts in thought. As future scientists push the boundaries of our understanding, they will challenge our existing theories and frameworks, leading to an evolution in how we view the universe and our role within it. Moreover, the ongoing research into the origins of the cosmos holds the potential to revolutionize many fields of study. By delving into the question of how the universe began, scientists not only gain insights into the birth of celestial bodies, but also into the very fabric of time and space. This research fuels new theories about the fundamental forces of nature, forces like gravity and electromagnetism, that may pave the way for breakthroughs in fields ranging from particle physics to astrophysics. But perhaps the most exciting prospect is the opportunity to unravel the mysteries of dark matter and dark energy, two enigmatic substances that make up most of the universe. These forces remain largely unknown, but their exploration could lead to transformative discoveries. By studying dark matter and dark energy, researchers might develop innovative technologies or methodologies that could have far-reaching implications. Advances in how we detect, measure, and manipulate these mysterious components could lead to new engineering solutions, revolutionizing technologies in telecommunications, energy generation, and beyond. Ultimately, the path ahead is one of uncertainty and discovery. As we continue to explore the vastness of the universe, the very theories that guide us today may be supplanted by new ideas, reshaping our understanding of reality itself. But one thing is certain. As we navigate this uncharted terrain, each new discovery brings us closer to a deeper and more profound understanding of the cosmos and of our place within it. Studying the earliest moments of the universe is not just about gazing into the distant past. It's a journey that invites collaboration across a wide spectrum of disciplines. By blending astrophysics, cosmology, philosophy, and even the arts, we are not merely scratching the surface of scientific inquiry. We are engaging in a rich, multi-dimensional dialogue. These interdisciplinary connections can serve as a spark for new ideas and breakthroughs, forging innovative paths that may not have been apparent in the confines of any single field. As ideas cross boundaries, concepts from one domain of knowledge often cast light on those in another, creating opportunities for entirely new experiments and explorations. This fusion of knowledge doesn't only push the frontiers of scientific discovery, it has the potential to redefine how we approach education itself. As we learn more about the origins of the cosmos, science curricula may evolve to reflect the interconnected nature of cosmic study. The understanding that everything, from biology to environmental science, is linked to the universe's vast and intricate workings encourages a more holistic approach to education. By nurturing curiosity about these grand, existential questions, we are laying the foundation for a future where scientific exploration is not merely about seeking answers, but about fostering the mindset to continually expand our understanding of the universe and of our place within it. The quest to understand the cosmic origins has profoundly altered the narrative of human history. Once humanity viewed the universe through the lens of myth and divine intervention, believing that deities or supernatural forces were the architects of creation. These ancient interpretations provided comfort and meaning for civilizations confronted by the mysteries of existence. However, as science progressed, these myths began to be replaced with frameworks grounded in observation, reason, and empirical evidence. The advent of modern astronomy and physics, particularly the introduction of groundbreaking theories such as the Big Bang, fundamentally reshaped our understanding of the cosmos. The Big Bang Theory, which posits that the universe began roughly 13.8 billion years ago from an infinitely dense point, challenges our deepest assumptions about time, space, and existence itself. This new model not only altered how we perceive the origins of the universe, but also ignited a wave of curiosity that has since permeated human culture. We moved from thinking about creation as the work of divine beings to understanding it as a process that can be observed, studied, and analyzed. Through the work of pioneers like Albert Einstein and Edwin Hubble, and more recently the discovery of the cosmic microwave background radiation, humanity began to realize that we are part of a much larger cosmic narrative, a story that unfolds not just in our own galaxy, but across the entire universe. This shift in perspective has had profound consequences beyond the realm of science. It has seeped into art, literature, and philosophy, influencing how we think about consciousness, existence, and our place within the vast tapestry of the cosmos. The idea that we share a common cosmic origin, that we are all part of a vast interconnected whole, has fostered a sense of unity among people across the globe. This recognition transcends geographical, cultural, and societal divides, reminding us of our shared heritage as inhabitants of this great universe. Furthermore, this understanding of our cosmic origins has not only transformed our worldview, but also spurred technological advancements. The quest to explore space and understand the universe is not just about the stars or distant galaxies. It's also about advancing human knowledge and improving life on Earth. The exploration of space teaches us not only about the celestial bodies, but also about our planet, our limitations, and our responsibilities. The realization that Earth is a fragile speck in the vastness of the cosmos drives home the importance of stewardship and sustainability. In the grand scheme of things, we are custodians of this planet, and that responsibility grows as we deepen our understanding of the universe. The evolution of human thought regarding our cosmic origins continues to have a transformative impact on our collective journey. As our knowledge deepens, it propels us to explore, reflect, and innovate. Every discovery, every breakthrough is a building block that shapes not only our understanding of the universe, but also the future of humanity. The tapestry of knowledge we have woven over centuries, from the early philosophers who gazed at the night sky and pondered the meaning of existence, to the cutting-edge scientists using advanced technologies to probe the cosmos, has given us a rich and layered understanding of our place in the universe. Each generation has contributed to this growing understanding, adding new layers of insight and challenging old assumptions. We now comprehend cosmic phenomena such as galaxies, black holes, and the very fabric of space-time, and this knowledge has expanded our vision of what is possible. At the heart of this advancement is the scientific method itself, a powerful tool that allows us to ask questions, formulate hypotheses, and test our ideas through experimentation and observation. It is this method that has led to some of the most groundbreaking discoveries in human history, from Newton's laws of motion to Einstein's theory of relativity and the quantum mechanics that govern the behavior of particles at the smallest scales. These developments have not only deepened our understanding of the universe, but have also led to technological innovations that shape our daily lives. The ability to apply these theories to real-world challenges has had far-reaching consequences, influencing everything from the development of computers to advancements in telecommunications and medical technologies. The impact of our understanding of the cosmos stretches far beyond the laboratory or the observatory. It shapes the very fabric of modern society, driving progress and creating a future where scientific exploration and human innovation continue to flourish. The collaborative nature of scientific research is a defining aspect of human progress. Knowledge, once gained, is not hoarded but shared, building upon itself in an ever-expanding web of discovery. This interconnectedness is particularly evident in the realm of astronomy and cosmology, where scientists, regardless of national or cultural background, work together in pursuit of understanding the vast and mysterious universe. Astronomers, physicists, and cosmologists often collaborate across borders, uniting their expertise, resources, and technology to explore the cosmos. Instruments like the Hubble Space Telescope and the James Webb Space Telescope stand as not just technological marvels, but as symbols of this global cooperation. These instruments capture data from all corners of the Earth and beyond, bringing us closer to the farthest reaches of space. Far from being mere tools, these telescopes represent a collective human effort, a beacon of shared knowledge and determination. The images they send back to Earth do more than showcase distant galaxies and nebulous clouds. They offer us profound insights into the early stages of galaxy formation and hint at the existence of exoplanets that may harbor life. Each of these discoveries adds to a growing legacy, one defined by curiosity, enlightenment, and the relentless pursuit of answers to questions that have intrigued humanity for millennia. This legacy is not simply an academic one, it is a cultural and philosophical force, inspiring future generations to look up at the night sky and wonder. The knowledge we continue to share about the origins and structure of the universe ignites the imaginations of scientists yet to come and stirs the minds of countless curious individuals who seek to understand where we come from and where we are headed. Ultimately, the pursuit of knowledge about the cosmos does more than enhance our scientific understanding. It serves as a unifying force, reminding us all that we are part of something much larger than ourselves, an intricate, expansive, and awe-inspiring cosmic story that transcends borders, cultures, and languages. This collective endeavor binds humanity together, making clear that despite our differences, we are all linked by a shared curiosity and a common destiny within the universe. Throughout history, humanity's growing understanding of the cosmos has often paralleled major societal and cultural shifts. For instance, during the Renaissance, the work of figures like Nicholas Copernicus and Galileo Galilei fundamentally changed the way we viewed our place in the universe. The transition from an Earth-centered view of the cosmos to one where Earth is just another planet orbiting the sun was revolutionary. This shift not only reshaped our understanding of the universe, but also challenged long-standing authority and opened the door to a new era of scientific inquiry. It set the stage for the Enlightenment, which brought with it a wave of intellectual curiosity and a commitment to challenging old beliefs. As we moved into the Industrial Revolution, technological advancements ushered in an era of even deeper cosmic exploration. The invention of powerful telescopes paved the way for more detailed observations of the universe, followed by the development of radio and space telescopes, which revealed previously hidden layers of the cosmos. With each new discovery came new questions, and each new instrument allowed us to peer further into the unknown. This growing technological sophistication not only advanced our understanding of the universe, but also spurred societal movements that emphasized the importance of science, technology, engineering, and mathematics, STEM education. The technological progress of this era served to inspire a generation to look beyond the confines of the Earth and reach for the stars. In the present day, the quest to understand the universe is more intertwined with our societal values than ever before. The global nature of scientific collaboration, embodied in projects such as the International Space Station and state-of-the-art observatories, reflects the collective commitment of nations to pool their resources and expertise. These collaborations break down geopolitical barriers in the pursuit of shared knowledge, demonstrating the power of cooperation in overcoming challenges and expanding human potential. Furthermore, these international scientific projects serve as metaphors for how the world must approach other global challenges, such as climate change, political tensions, and resource distribution. The same spirit of collaboration that drives space exploration is also essential for addressing the pressing issues facing humanity here on Earth. Just as the exploration of the cosmos demands unity and collective effort, so too does the survival and flourishing of our species in the face of shared global problems. In times of existential reflection, such as during the COVID-19 pandemic, societal interest in cosmology often surges. As people grapple with the fragility of life and the vastness of the universe, many turn to science for solace and understanding. The immense scale of the cosmos, with its billions of stars and galaxies, offers a perspective that can both humble and comfort us. At such times, the exploration of the universe becomes more than just an intellectual pursuit. It becomes a deeply human endeavor, one that reflects our shared fears, hopes, and aspirations. The relationship between scientific progress and societal values is symbiotic. Each influences and shapes the other. Our continued journey into the cosmos is not just about distant stars and planets. It is also a reflection of who we are as a species, the questions we ask and the answers we seek. It is an expression of our desire to understand the universe, and in doing so to better understand ourselves. The discoveries we make in the realm of cosmology are not just milestones of scientific achievement, they are milestones of human growth and evolution. Each new breakthrough in cosmology has the power to inspire the next generation of scientists, fueling their imaginations and prompting them to ask the big questions. How did the universe begin? What is the nature of time? Are we alone in the cosmos? The discoveries of phenomena like gravitational waves or the first images of distant exoplanets have a profound impact on young minds, sparking their curiosity and fueling their desire to explore. These revelations offer glimpses into the very fabric of reality, turning the universe into a vast, fascinating puzzle waiting to be solved. For many young people, the mysteries of the cosmos become a lifelong passion, motivating them to pursue careers in science, technology, and engineering. The quest to understand the universe is not just about looking up at the stars, it is about unraveling the deepest mysteries of existence. With each new discovery, we get one step closer to understanding the fundamental laws that govern our reality. And in doing so, we continue to inspire the next generation of thinkers, dreamers, and explorers. Scientific exploration is not just an intellectual pursuit. It is a journey of collaboration, innovation, and boundless curiosity. The discoveries we make in the realms of physics, astronomy, and cosmology often highlight how scientific inquiry is a shared endeavor that transcends geographical boundaries. Aspiring scientists around the world watch in awe as teams of researchers from every corner of the globe unite to confront complex challenges. Equipped with cutting-edge technology and innovative methodologies, these researchers strive to unravel some of the universe's greatest mysteries. This collective approach to problem solving is vital, as it demonstrates that no scientific breakthrough is ever truly isolated. Instead, every discovery is a product of teamwork, collaboration, and a shared commitment to pushing the boundaries of knowledge. For young minds, seeing the power of collaboration in action fosters an appreciation for teamwork, an essential skill in any scientific pursuit. The stories of those who dedicate their lives to understanding the cosmos offer profound lessons in perseverance and creativity. They show that the path to scientific breakthroughs is rarely straightforward. Obstacles are inevitable, but these challenges are often overcome through dedication, ingenuity, and the collective efforts of brilliant minds working in tandem. Moreover, the impact of cosmological discoveries stretches far beyond the confines of theoretical science. Often, these findings lead to groundbreaking technological advancements that directly affect our daily lives. Take, for instance, the technologies developed to analyze cosmic microwave background (CMB) radiation. Initially designed for astrophysical research, these innovations have led to significant advancements in medical imaging and telecommunications. When young people understand that discoveries which seem abstract or esoteric can have real-world applications, it ignites a powerful sense of possibility. They realize that the questions they explore today could lead to innovations that will shape society tomorrow. This connection between abstract science and practical, tangible outcomes is one of the most motivating aspects of scientific inquiry. It serves as a call to action for those who may one day contribute to the fields of science, technology, engineering, and mathematics, STEM, inspiring them to pursue careers that could alter the course of history. The vastness of the cosmos also provides fertile ground for profound philosophical reflections on the nature of existence and humanity's place within the universe. Questions about the possibility of extraterrestrial life, the ultimate fate of the universe, and the very origins of our existence are no longer the exclusive domain of philosophers or theologians. They have become essential considerations for scientists and thinkers of all stripes. As young individuals engage with these questions, they are encouraged to think critically and to question the assumptions that underlie our conventional understanding of the world. This engagement with big existential questions cultivates a mindset that is open to exploring ideas that extend far beyond the traditional confines of educational curricula. The intersection of science with philosophy fosters a holistic approach to learning, one that encourages young minds to consider not just the practical, but the profound implications of the knowledge they seek. As humanity continues to make groundbreaking discoveries, our relationship with space and time evolves in ways that were once thought to be purely speculative. Recent advancements in technology have provided us with deeper insights into the structure of the universe. We are now approaching the point where we might no longer view space as a distant frontier, but as an interconnected web that subtly influences our daily lives. For instance, innovations in spacecraft design and the exploration of celestial bodies may soon allow humanity to establish a permanent presence beyond Earth. This would fundamentally alter our perception of home and community. The idea that we might one day live on another planet or in a space station orbiting Earth challenges our understanding of what it means to be human and where our place in the universe lies. Furthermore, developments in the study of black holes and gravitational waves are reshaping our understanding of time itself. Time, once thought to be a constant, is now known to be a fluid, malleable entity that can stretch and warp depending on the gravitational forces acting upon it. This realization adds a new dimension to the human experience as it forces us to reconsider how we understand time in relation to our lives. Could our experiences, memories, and life cycles be influenced by the vastness of the universe? Could the passage of time be different for those living on other planets or even on space stations orbiting Earth? As we explore these questions, we begin to appreciate that time is no longer a linear, immutable force, but rather a dynamic element that we may one day navigate in ways we cannot yet fully comprehend. Perhaps most intriguingly, the investigation into dark matter and dark energy is pushing the limits of our scientific knowledge. While we have made incredible strides in understanding the visible universe, we are only scratching the surface of what is out there. These mysterious substances make up a vast portion of the cosmos, and unlocking their secrets could lead to breakthroughs that fundamentally alter our understanding of physics. Imagine the potential for new technologies that could harness the properties of dark matter or allow us to manipulate time and space itself. Such developments might seem like the stuff of science fiction, but they are becoming increasingly plausible as our understanding of the universe deepens. This deepened understanding of the cosmos also invites us to explore questions that sit at the intersection of science and philosophy. If we are on the brink of discovering new ways to manipulate time and space, what does this mean for our very understanding of life, death, and existence? Could our growing knowledge of the universe force a reevaluation of age-old philosophical questions about causality, existence, and the nature of reality? The possibilities are vast, and As scientists continue to make new discoveries, they challenge not only our knowledge of the physical world, but also the very framework of how we think about our place in it. At the heart of this journey lies one of the most profound questions: what came before the Big Bang? As researchers delve deeper into this cosmic enigma, they confront questions that stretch the boundaries of both science and human thought. Was the Big Bang truly the beginning of time and space, or was it merely the latest in a series of cosmic cycles? Could the universe be part of a larger multiverse, or is the nature of existence itself radically different from what we have imagined? These questions don't just have scientific implications, they also carry metaphysical weight, pushing us to reconsider our assumptions about the universe and our place within it. Philosophers and scientists alike are exploring these ideas, pondering the implications of theories such as quantum fluctuations, cyclical models of the universe, and the potential existence of parallel universes. Each of these perspectives raises profound questions about the nature of time, space, and causality. As we grapple with these complex ideas, we are forced to confront the very nature of existence itself. What does it mean for something to come into being, and what does it mean for it to emerge from nothingness? These are not just abstract academic inquiries. They are questions that strike at the heart of what it means to be human and to exist in this vast, mysterious universe. In the end, the exploration of space is not just a quest for scientific knowledge, but a profound journey into the very nature of reality. As we continue to push the boundaries of human understanding, we are not only learning more about the cosmos, but also about ourselves. The discoveries we make today will shape the world of tomorrow, inspiring future generations to continue this remarkable journey of exploration and understanding. The universe is not just an expanse of stars and galaxies. It is a gateway to new ways of thinking, living, and understanding the world around us. And as we continue to explore it, we may one day discover that the greatest mystery of all lies not in the stars, but in the very nature of our own existence. As we engage with pre-Big Bang theories, we find ourselves delving into not only the foundations of the universe, but also revisiting age-old philosophical debates about determinism versus free will. These debates, which have pervaded human thought for centuries, become even more compelling when we consider the very nature of existence itself. Could consciousness, long thought to be a byproduct of the brain, actually be a fundamental aspect of reality, influencing the unfolding of the cosmos from the moment of creation? This idea invites us to ponder whether our perception of reality shapes the universe, or if perhaps the cosmos unfolds according to a predetermined path that we are powerless to alter. As scientists uncover more about the universe's beginnings, we are challenged to reconsider how consciousness interacts with the physical world. These new theories are not merely academic exercises. They push the boundaries of human thought, blending science and philosophy in ways that have the potential to reshape both fields. For those who think about the intersection of science and philosophy, this dialogue is increasingly important. The more we explore these complex, often abstract ideas, the closer we come to understanding human existence and consciousness, while also offering fresh perspectives on ancient doctrines that have long been a part of philosophical tradition. In fact, embracing such intricate and speculative concepts has the potential to enhance not only our intellectual curiosity, but also our appreciation for the profound mysteries that continue to surround us. These inquiries do more than merely stimulate thought. They illuminate the depths of our philosophical heritage and offer new pathways for understanding that we are just beginning to explore. As we continue to probe these mysteries, they may ultimately lead to a bridging of the gap between science and philosophy, forging new pathways in future discourse that we have yet to fully grasp. At the heart of many unresolved cosmic mysteries lies the boundless potential for wonder and discovery. One of the most profound enigmas facing scientists today is the question of dark matter. Around 25% of the universe is believed to be made of this invisible substance, which does not emit, absorb, or reflect light. Despite its elusiveness, scientists infer its existence by observing its gravitational effects on visible matter. Unraveling the true nature of dark matter would not only revolutionize our understanding of the universe, but it could also lead to new physics that surpasses current models, revealing hidden forces that govern the very structure of reality. Similarly, the discovery of dark energy, the elusive force driving the accelerated expansion of the universe, continues to puzzle researchers. This mysterious force accounts for approximately 70% of the cosmos and plays a central role in determining the ultimate fate of the universe. Will the cosmos continue to expand indefinitely, or will it one day collapse in on itself? Solving the riddle of dark energy could change the way we think about the very fabric of space and time, raising fundamental questions that bridge cosmology and our understanding of the universe's origins. Then there are the black holes, regions in space where gravity is so intense that nothing, neither matter nor light, can escape. Black holes challenge our understanding of physics, particularly as scientists gain unprecedented insights through the imaging of a black hole's event horizon. Yet, despite these breakthroughs, profound questions remain about the singularities found within these cosmic giants and how they relate to the fabric of space-time itself. Research into black holes is not only reshaping our understanding of quantum mechanics and general relativity, but it may ultimately provide the key to a unified theory of physics, one that could unite the forces that govern the universe in a single comprehensive framework. Finally, the ongoing search for extraterrestrial life fuels our curiosity and imagination. The discovery of exoplanets and habitable zones has brought us closer to the tantalizing possibility that we may not be alone in the cosmos. Missions aimed at detecting biosignatures, the chemical markers that could indicate the presence of life, are pushing the boundaries of what we know about the potential for life beyond Earth. As we explore the vastness of the universe, these discoveries promise to redefine our understanding of what constitutes life, where it might exist, and how it might manifest on planets far removed from our own. Each of these mysteries, whether it pertains to the very structure of matter, the forces shaping the universe, or the existence of life beyond Earth, holds the potential to reshape the trajectory of human inquiry. As our technological capabilities advance and our understanding of the universe deepens, these enigmas will continue to spark new hypotheses, pushing the limits of human creativity and scientific exploration. Understanding the origins of the cosmos requires more than a mere collection of scientific facts. It calls for the integration of diverse perspectives. Scientific data, such as those that describe the Big Bang or the formation of galaxies, reveal the physical processes that shape the universe. But these facts, while essential, do not address the deeper questions that concern meaning, purpose, or our place in the grand scheme of things. To answer such profound inquiries, we must also turn to philosophical frameworks that examine the nature of existence and the role of consciousness within that vast expanse. Philosophically, we are invited to ask questions that science alone cannot answer. Why does the universe exist at all? What is the role of consciousness in the grand narrative of cosmic evolution? These existential questions stimulate dialogues that stretch the boundaries of both science and philosophy, encouraging a richer, more nuanced understanding of our place in the universe. By blending scientific inquiry with philosophical reflection, we gain a deeper appreciation of the cosmos and our connection to it, an appreciation that transcends the limitations of empirical data. Art and culture also offer significant contributions to our understanding of cosmic origins. Writers, filmmakers, and artists throughout history have drawn inspiration from celestial phenomena, weaving narratives that engage the imagination and evoke deep emotional responses. Have you ever looked up at the night sky feeling a spark of creativity ignite as the stars twinkled above? This emotional connection to the cosmos fosters a sense of wonder and curiosity that drives us to explore the universe further. Through stories, representations, and imagery, art helps us visualize our cosmic journey in ways that science alone cannot capture, adding a layer of emotional depth that fuels our desire to learn more about the vastness of space and our place within it. Thus, the exploration of cosmic origins is not just a scientific pursuit, it is a multidisciplinary quest that brings together science, philosophy, and the arts. By weaving these various threads together, we begin to understand the universe not just in terms of atoms and galaxies, but in terms of meaning, wonder, and our shared human experience. Humanity's pursuit of understanding the universe is not just a scientific endeavor, but a deeply shared experience across cultures, each contributing a unique perspective on the cosmos. For millennia, civilizations have developed their own mythologies, cosmologies, and narratives about the stars, planets, and the origins of everything. These varied interpretations are as diverse as the cultures that birthed them, each providing its own lens through which we observe the vast unknown. When we step back and recognize these disparate viewpoints, we uncover a richer, more intricate understanding of cosmic origins, one that celebrates human diversity and collective curiosity. The exploration of the cosmos becomes, in this way, not a solitary pursuit, but a global journey that unites us all in our quest to unravel the mysteries of the universe. This diverse collection of ideas serves not only as an intellectual resource, but also as a bridge to greater unity among people. Regardless of where we come from or the cultural frameworks through which we view the world, we all share the same sky. This realization fosters an ongoing sense of belonging within the broader narrative of cosmic discovery. As we peer into the vastness of space, it is not only our shared sense of wonder that binds us together, but also the understanding that we are all participants in a grand, unfolding story of universal exploration. Aesthetic experiences play a vital role in this endeavor, especially when we contemplate cosmological concepts. They evoke profound emotional and intellectual responses that transcend the language of science, allowing us to connect with the universe on a deeply personal level. When we witness the swirling brilliance of galaxies or the serene, ethereal glow of nebulae, we are not merely observing distant celestial phenomena. We are engaging with them, feeling the enormity of their presence, and inviting them into our own consciousness. These cosmic visions stir something primal within us, prompting existential questions about who we are, our place in the vastness of space, and the deeper meaning of life itself. The beauty of space is not just an aesthetic wonder, but a powerful catalyst for intellectual curiosity. The images transmitted by instruments like the Hubble Space Telescope transform raw data into breathtaking works of art that make complex astronomical concepts more accessible and understandable. This fusion of art and science plays a crucial role in inspiring exploration and inquiry. When we gaze upon these visuals, we are invited to look beyond the surface and delve into the science that underpins them. The formation of stars, the makeup of interstellar dust, the forces that govern black holes. By connecting to the cosmos through beauty, we engage emotionally, creating a space for wonder and learning to coexist. This emotional connection makes us more receptive to the challenging and often abstract scientific ideas that explain these phenomena. And yet, it is not just the science that captivates us. It is the deep philosophical implications of cosmology that truly stir the imagination. For example, when contemplating the infinite expanse of the universe with its countless galaxies, one cannot help but reflect on the nature of existence, the concept of time, and our collective purpose. These moments of awe inspire shifts in perspective, leading us to reconsider our understanding of time, space, and our interconnectedness with all that surrounds us. This change in perspective is not just theoretical. It has the power to foster a more profound appreciation for life and coexistence, urging us to consider how our actions affect the world around us. As we consider the beauty and vastness of the universe, we come to realize that we are part of something far greater than ourselves. In this way, the cosmos becomes not just a scientific study, but a moral and philosophical guide, offering insights that encourage us to live more thoughtfully and in harmony with one another and the world. The union of art and science within our understanding of the cosmos is more than just a convergence of two fields. It reveals their symbiotic relationship. Each has the power to illuminate the other. Art deepens our emotional connection to scientific concepts, making them more relatable, while science fuels the creative spark of art, providing it with new subjects and new ways of seeing. Together, they create a fuller, richer picture of our universe, inspiring creativity, exploration, and deeper inquiry. The beauty of the cosmos, then, serves as more than an aesthetic experience. It becomes an invitation, a call to explore, to discover, and to understand the scientific principles that govern the universe. This beauty is not passive. It drives a continuous, lifelong journey of exploration and wonder, igniting curiosity and fueling the drive to discover more. One of the most fascinating aspects of cosmology is the concept of interconnectedness, especially when considering theories about the early universe. In the first moments after the Big Bang, the universe was a seething, dense, and extraordinarily hot place where particles interacted in ways that are hard to imagine. During this phase, known as cosmic inflation, the universe expanded at an incredible rate, rapidly increasing the distances between particles and laying the groundwork for the structure of the cosmos as we know it. A striking manifestation of interconnectedness from this period is the unification of the four fundamental forces: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. Physicists theorize that at high energies during the early universe, these forces were not separate, but were all part of a single unified force. This realization suggests that, at one point in time, the universe operated as a cohesive, interconnected whole. As the universe cooled, these forces broke apart, and the distinct forces we observe today emerged. However, their shared origin hints at a deeper connection within the very fabric of reality itself. Another fascinating element of interconnectedness is quantum entanglement, a phenomenon in which particles become intertwined in such a way that the state of one particle instantaneously influences the state of another, no matter how far apart they are. In the early universe, when particles were much closer together and highly correlated, entanglement played a major role. As the universe expanded, these entangled states stretched across great distances, establishing a fundamental link between distant regions of space. Even as the universe evolved and matter coalesced into galaxies, the echoes of this early interconnectedness remained, creating an enduring connection throughout the cosmos. The universe, then, is not a collection of isolated phenomena. It is a vast, interconnected whole, where the relationships between forces, particles, and space-time are woven together in a way that continues to shape the evolution of the cosmos. This deep interconnectedness offers us a glimpse into the underlying unity of all things, inviting us to consider not just the mechanics of the universe, but also our own place within this grand interconnected fabric of reality. The cosmic microwave background radiation, often regarded as the relic of the early universe, provides us with a crucial glimpse into a moment in time approximately 380,000 years after the Big Bang, when the cosmos transitioned from an opaque, foggy state into the clear expanse we observe today. This radiation, though uniformly spread throughout the universe, carries with it minute variations, tiny fluctuations that, in their subtlety, reveal the density differences that ultimately gave rise to the galaxies, stars, and structures we see across the cosmos. These minute-to-minute disparities serve as a testament to the interconnectedness of the universe, a reminder that the universe we experience now is still shaped by the initial conditions laid out at its birth, impacting not just its present form, but its vast, complex dynamics that stretch across billions of years. As researchers venture deeper into understanding these fluctuations, they uncover a rich and intricate web of connections that trace the history of our universe from its very beginnings. The story of our cosmos, woven together through countless interactions, relationships, and histories, unfolds before us as a narrative that spans the ages, all rooted in that monumental event, the Big Bang. The pursuit of this knowledge mirrors humanity's broader quest to understand our place within the vast expanse of existence, a journey that has driven scientific inquiry since the dawn of civilization. At its core, science has always been an attempt to unravel the profound mysteries of the universe, powered by an innate curiosity that transcends time and connects us all, whether ancient or modern, to the stars above. Much like our ancestors gazed up at the night sky, trying to make sense of their surroundings and their purpose within it, today's scientists grapple with theories that stretch the limits of our knowledge. Theoretical physicists, in particular, tackle some of the most challenging questions about the very nature of reality, questions that often seem to defy common sense. The strange behaviors of black holes, or the bewildering complexities of quantum mechanics, for example, present deep paradoxes that challenge our understanding of space, time, and even existence itself. These issues, while deeply academic, are reflections of a more universal human desire to seek meaning, order, and coherence in a world that so often seems chaotic, unpredictable, and full of uncertainties. In grappling with such profound concepts, scientists find themselves facing obstacles that push the very boundaries of knowledge, requiring them to rethink and refine their understanding of reality. This process of inquiry and discovery mirrors the personal growth that we all experience as individuals. Just as humans must adapt and evolve in response to life's challenges, so too do scientific theories evolve through trial, error, and perseverance. These ongoing challenges serve as a reminder that growth, whether intellectual or personal, comes through adversity, and that the pursuit of knowledge is as much about the journey of discovery as it is about the destination. In the contemporary world, this journey of scientific exploration intersects with some of the most pressing issues of our time: climate change, technological progress, and ethical dilemmas. The theories and discoveries emerging from scientific research serve not only to advance our understanding of the natural world, but also act as reflections of our collective struggles. In facing these global challenges, science compels us to question long-held assumptions, embrace uncertainty, and pursue a deeper, more comprehensive understanding of the world and our place within it. These endeavors remind us that the path to knowledge is not always straightforward, and that the true value lies in the questions we ask and the ongoing search for meaning. As science progresses, it increasingly becomes clear that the boundaries between different fields of knowledge are not as rigid as they once appeared. Interdisciplinary dialogue, where science, philosophy, art, and spirituality converge, can lead to a more holistic understanding of the universe. Each discipline brings its own unique perspective to the table, contributing to a broader and more nuanced view of existence. For instance, when cosmologists study the origins of the universe, they focus on physical laws and observations. Yet at the same time, they inevitably confront questions about meaning, existence, and consciousness that fall squarely within the domain of philosophy. The fundamental question, what does it mean to be part of a universe that began with a Big Bang, is one that philosophers are uniquely equipped to explore. Moreover, the arts bring a different, deeply subjective layer to this conversation. Where science deals in cold data and theoretical models, the arts explore the emotional and existential dimensions of our experience. Through painting, literature, and music, artists capture the wonder and complexity of the cosmos, evoking a sense of awe that can transform how we feel about our place in the universe. When these two realms, science and art, collaborate, the resulting dialogue enriches both disciplines. Artists can provide a lens through which scientific discoveries can be felt as well as understood, while scientists can help artists ground their metaphors and ideas in the latest discoveries. This synergy between different fields of study is not just a way of making sense of the universe, it's a way of enriching our experience of it. The interplay between disciplines encourages new questions and fresh approaches, fostering innovation and creativity in ways that a singular perspective might not. This merging of art, science, philosophy, and spirituality leads to a deeper exploration of the profound mysteries that lie at the heart of our existence and the universe itself. It allows us to approach the question of life's meaning from multiple angles, embracing the complexity of existence and welcoming the ongoing curiosity that drives us to explore it. When we think about the origins of the cosmos, we are often struck by the sheer vastness and seeming indifference of the universe. It can be overwhelming to consider that the universe operates according to impersonal physical laws, many of which are far removed from human emotion or concern. Yet, amid this cosmic indifference, humanity has found a remarkable ability to seek meaning. Despite the cold and distant realities of space, human beings possess an extraordinary capacity for reflection, imagination, and creativity, allowing us to search for purpose even in the most seemingly inhospitable environments. Scientific exploration plays an essential role in this process. By studying the stars, galaxies, and the evolution of the universe, we come to understand our place in the grand narrative of existence. The atoms that make up our bodies were forged in the heart of long-dead stars, linking us directly to the cosmos in a tangible, physical way. This realization deepens our connection to the universe, reminding us that we are not separate from it, but are part of a greater cosmic story. Through the lens of science, we begin to see that we are, in many ways, made of stardust, a physical manifestation of the same processes that have shaped the universe for billions of years. As we continue to unravel the mysteries of the cosmos, we are not just learning about the stars and galaxies, we are also learning about ourselves. In seeking to understand the universe, we uncover deeper truths about the nature of existence, the meaning of life, and our place in this vast, ever-expanding universe. This quest for knowledge, fueled by curiosity and wonder, is an intrinsic part of what it means to be human, a journey that will continue as long as we are able to look up at the stars and ask, what lies beyond? Storytelling in all its forms remains one of the most powerful ways through which we come to understand the world around us, interpret our experiences, and share our collective wisdom. It has existed across all cultures throughout time, from the earliest myths to the most intricate philosophies, and even in the creation of art. Each of these expressions, rooted in the human desire for meaning, has arisen to serve a deeper purpose, to illuminate the intangible, to offer insight into our place in the universe, and to connect us in a way that is both personal and universal. Across the expanse of human history, myths have been born from the fires of curiosity and survival. They tell of gods and heroes, of cosmic battles and life lessons, each representing the profound questions that stir in our hearts. In a sense, these myths and legends are the voices of our ancestors, echoing down through the ages, bearing the collective hopes, fears, and dreams of generations long past. We find ourselves, even today, looking to them for answers, not just to explain the natural world, but to understand the mysteries of existence itself. Philosophies, too, have emerged as a reflection of humanity's relentless pursuit of truth. They delve into the very nature of life, ethics, and the universe, attempting to map out a framework within which we can make sense of our experience. These philosophical systems, whether grounded in Eastern wisdom or Western rationalism, offer different paths to enlightenment, but they all share a common theme: the search for meaning in a vast and often incomprehensible world. Art, too, holds a special place in this journey. Through paintings, sculptures, music, and literature, humanity has sought to capture the essence of existence. Art becomes a language in its own right, one that transcends words and speaks directly to the soul. It allows us to express what cannot always be articulated, whether that be joy, sorrow, hope, or despair. In this way, art becomes not just a reflection of life, but a means of engaging with it, of shaping and reshaping our understanding of the world and our place in it. And yet, despite the beauty and depth of these creative expressions, the universe itself remains vast, cold, and indifferent. The stars twinkle above us, distant and silent, seemingly unaffected by the dramas that unfold on our tiny blue planet. The cosmos, in all its infinite complexity, can feel overwhelming, almost alien. We stand, as mere specks in the grand scheme of the universe, contemplating our fleeting existence against the backdrop of time and space. However, it is precisely within this vast and indifferent cosmos that we find the power to create meaning. Though the universe itself may seem indifferent to our struggles and triumphs, it is within the depths of the human mind and heart that the true significance of life is forged. It is through our relationships, our achievements, and our constant quest for knowledge that we craft a sense of purpose that transcends our individual lives. These connections, whether with others, with nature, or with the very cosmos itself, form the foundation of our existence, giving us the strength to continue seeking, questioning, and learning. In the end, the universe provides the stage, but it is the human spirit that breathes life into it. Our pursuit of connection, understanding, and meaning continues to be the driving force that propels us forward, even as we gaze up at the stars. For despite the silence of the cosmos, we persist in our search for answers, driven by the belief that, through our stories, we can find the answers that resonate deeply within us all. It is this very human spirit that seeks to understand the vast and silent dance of the stars, finding meaning even in the face of the unknown.